5-minute counter. Check in there for your mic. Autumn.
I know. Hello, hello. Can you hear me now? Damn it. Okay. Hello. You should have seen how many times we had to re-record our podcast because I'm always too quiet. And all they can hear is my laughs.
It will, it'll quiet up a little bit once I close the doors, but if you guys want to move forward a little bit too, that might help as well, if you're having trouble hearing.
Yeah, I have no in between. It's just too loud or too quiet. Sorry. The sticker is freaking amazing. I'm so excited. It's awesome. Justin, we need stickers next. Dwayne has stickers. Like, this is the... It's a beard and a wizard hat. You had a wizard hat? I've been doing life wrong. He's got a wizard hat. This is just clearly where I messed up. Oh. I couldn't get on like twice yesterday, and I was like, I should just finish my slides before the day before. Be on my side. Okay.
Do we have any SCaLE first-timers? There's a bunch of you. You know they have fancy ribbons over by the information desk that say first-timer. And I bet if you wear them, people will be like really nice and give you extra swag and won't even scan your badges and send you spam emails. Although probably not.
I didn't think people were actually going to show up. A lot of people.
How many people are SoCal locals? Oh, a bunch. All right.
I'm jealous of all of your access to tacos. Where's the rest of our posse? I love how you guys were so much more fun. Like, I was like, I want to go to bed and finish my slides.
All right, who thinks that they came from the farthest away?
Where'd you come from?
All right, we have a DC. I think France wins.
Yeah. Totally win. It's my first. Be proud of me. It could have been my second. Justin doesn't drink coffee. Judge him, Dwayne. Judge him. You have kids and you work in tech. You should have seen yeah. Exactly. You should have seen the adventure we went on looking for Dr. Pepper yesterday. I'm scared. Okay. I'm with me everywhere? You're a wizard. You can just show up. Like. Huh? Oh no. That's not better. My God, this last minute's taking forever. I can't tell if I'm cold or hot. Don't say that. Then now I'm gonna do it. Can't tell if I'm cold or hot or just nervous. Like.
It's 11:15. Let's close this door and get started. It's Saturday at SCaLE 21. This is Autumn Nash, Empowering Women in Data, Shaping an Inclusive AI Future. So please give a warm welcome, and we'll let Autumn take it away.
Thank you all for being here. I'm really excited to talk to you guys about data because I'm a total data nerd. So first I want to kind of tell a little bit about my story because I think it's, when you tell a story, it gives you context to some of the, not maybe solutions, but ways that I think other people can help. Because first I want to tell you why this is a problem, right? And then I want to follow up with what we can all do to help and to make it better. So this is kind of like my context to the making it better part. So I was a military spouse for 14 years. And when you're a military spouse, you're moving around a lot. You're constantly, you don't have family, you don't have childcare. I had my own business and art degree, which, as you all know, when you do art, you're poor. So I was like, I've got to go back to school. I've got to do something different. And I've been obsessed with computers since I was a little girl. I got my first, you know those iMacs that were different colors back in the day? I got a teal one and I was like obsessed. I was like, look at all the gears and circuits and things in the background, you know, and like, I just thought it was so cool. And I've loved video games and coding, and I did everybody's MySpaces. So I was like, I'll go back to school for that. One day I was complaining on Facebook about homework and why my Java code wouldn't compile, and people were like, you should go check out this group called Milspouse Coders. And I went for homework help and came back with best friends. Then I got the bug of teaching. So we do coffees and codes, we teach, and we did hackathons. So we started our hackathon in 2014, I think. 2017 was our first one. And I got to teach military spouses how to code, and I just really enjoyed it and loved it. So fast forward a year, and we were doing a PCS, which is a military move, and we were moving across the country. And it was right after our first hackathon, and Microsoft decided to fully fund our hackathon. And I was looking for an internship, but I couldn't get an internship because I was moving across the country. So I was pregnant with my second son. And I was like, just give me 6 weeks and we can do this hackathon. So that baby in that picture is my son, and it's his first hackathon. So I had moved across the country, and I was in school, and I was trying to do all the right things, but I couldn't even get an internship. And you can't get a job without an internship, right? So fast forward, somebody contacted me about apprenticeships. And they were like, there's an apprenticeship for this solutions architect job. And I was like, what is a solutions architect? I was like, I didn't even know what that was. I was like, I want to be an engineer. And they were like, just try it. It's a paid apprenticeship. And I was like, at least I could pay for childcare, you know? So I went, and that's started my obsession with data. I became a NoSQL specialist solutions architect at AWS, and it opened the world of data and what you can do with it. MilSpouse Coders has now gotten so many military spouses and women jobs that we are the first nonprofit that has been introduced into the military spouse employment program that is run by the Department of Defense, which shows that if the Department of Defense is funding something on it, that's how bad of a problem it is. Military spouse unemployment is 27% versus the 7 to 4% that normal people face. And they're 51% underemployed, which means you probably have a master's degree and you're working at Target, and it sucks. My favorite project is my 3 little boys. I'm a mentor for rewriting the code. I judge the Black Hack hackathons and do workshops and coach. And I'm also the Ship It co-host, which you might recognize that dude. We talk about everything after Git push. So in this talk, we're going to talk, is gender a problem in tech? I think we've all seen all the programs about getting women into tech, getting people of color into tech, but it seems like we're not really moving the numbers. And the thing that is most concerning is it's not just getting into tech. Our retention rates are horrible. Why is it important for us for data to be correct? And what is the relationship between data and AI? And how can women and diversity help that? And how could this go wrong? We'll just pretend like we haven't read any of the news articles in the last month. And how can you help? Because I think it's one thing to talk about a problem, but if we don't have a solution, if we don't work together to make it better, the problem will just continue to be exacerbated. Okay, let's start off with something fun. I want you guys to guess when this book was published. Just throw out a ballpark. No. You're really close. What'd you say? No. So 1999, which is funny. Did you know there were more women in tech in 1989 than in 2009? That's depressing. Like, we have put millions of dollars into these programs, and then the recession hit, and they were like, just kidding. Okay. So we've all heard all of the stories. It's the pipelines. We don't have enough. Did you know that top universities turn out more women, Black and Hispanic computer science majors at twice the graduate rate than the amount of them that are hired by technology companies? So there isn't a pipeline problem. The graduates are there, but we're not hiring them. This slide is kind of stuff that I'm sure you've all heard something about at some point. Women make up 25% of tech. So that's 1 in 4 of technical roles. I think the total of all tech roles, of all tech is like 27, but technical roles are 1 in 4. By the age of 35, you're at 1 in 8. Because 50% leave. By mid-career, it's 56%. So if you're already starting off with a really small percentage and then you keep cutting it over and over again, and women were affected by 45% of layoffs, so that doesn't sound like a lot, but we were already starting with such a small number to begin with. And representation matters. If you can't see yourself somewhere, how are you supposed to dream of being there? And Black, Latina, and Indigenous women are only 4% of technology. And in the UK, they were 0.77%. Also, Fun fact, I looked for the statistics on black women engineers and it's not even a statistic. Like, I actually looked and the only statistic I could find was 1.6 for the amount of all black women in STEM, scientists, engineers, and I mean like chemical engineers, like every type of engineer. So there's not even a statistic for black software engineers. And I've never seen another black software engineer, like woman, in real life ever. I think I've been in a meeting once where I was getting yelled at by other black software engineer like managers, and I was like, well, I wasn't getting yelled at, but our team was, let's say we were having a nice discussion. But the whole time I was like, oh my God, there's other brown people. Like, I couldn't even focus that I was getting yelled at because I was like, I've never seen them in real life before. That's not good, guys. Like, so think about this. Have you ever sat there and saw something in an app or in software and said, who did this? And did nobody tell them it was a bad idea? We've all had that moment, right? You're just like, no one in the room was like, maybe we shouldn't do this. Now, everyone's arguing that we're in a recession, right? This is a time that we need to make profitability our main aspect, which is how they justify layoffs, right? But we're ignoring the fact that we have proven data by Harvard Business Review, Forbes, and you guys know what I mean, economics, that women in your company and women leading companies give you a higher return on investment. Women-led startups have a 12% higher revenue. So if you're taking your bottom line into consideration, it is more profitable to have women on your team, to have women in your company. Also, Harvard Business has said over and over again that diverse teams are smarter and they innovate faster. You are going to build better software with diverse perspectives. You're going to have someone in the room that says, hey, maybe this is a bad idea. Maybe we should do more testing. Maybe we should work on this. Also, in the mind of profitability, women influence 85% of discretionary spending. So think about it. You're just basically telling your audience and the people that you want money from, we don't really care about your opinion. That's not good business practice for anybody. Have you ever seen, like, for instance, when you're a real estate agent, or most real estate agents will purposely cater more to a woman if there's a couple buying a house because they know women buy houses. In technology, we're just going to ignore a huge part of our audience and the people that we want to buy our products. Tech has faced layoffs where we've laid off 153,000 people. It's disproportionately affected women, people of color, and people on HP-1 visas. But not just that, who are the first teams to be cut? Diversity, equity, and inclusion teams, apprenticeships, returnships, and all the different programs that we had to have to get different people of different backgrounds to come in. Which doesn't make sense, especially how we've already talked about how that relates to your bottom line and making better software. This also signals to women and people of color that companies only cared about it when it was convenient. You're signaling to them that this was not a real issue that you actually believed in. How does this relate to open source? Because this is an open source conference. 70% of software that builds our infrastructure is open source software. Yet only 9.8% of it is contributed by women. So that means that we have a huge disparity of women and men, of women compared to men's contributions in open source. I think open source is one of the most beautiful forms of software development because it's a way that everybody gets to contribute to one common goal no matter where you are all over the world. And I think it will be one of the most important parts of AI because it means everybody has a chance to contribute to this new form of technology. This is an article from 2017, and that we were already talking about how data was the most valuable commodity. Has anybody seen the talk about Reddit and them IPOing? Reddit has been technically non-profitable for years, right? But what is making them profitable right now? Why do they have a $5 billion evaluation? Because of their data, right? AI needs data because it can't learn and make decisions without that data. So the data is invaluable because you need good data to make good AI. How could this go wrong? Has anybody seen any crazy news articles lately about, I don't know, Gemini going wrong, all the different chatbots? Hiring and recruiting. So there was a UK makeup artist, and she had already had the job, and she got furloughed. And they said, hey, come back and reapply after the furlough period. She goes back, she reapplies, and one of their AI hiring told her that she had body language that didn't fit their hiring standards. So she already had the job. They told her to come back, but they told her she wasn't qualified to be a makeup artist because of hand gestures she made during her interview. We already know that hiring and recruitment is something that is already biased for women and people of color. So as much as we could probably advance and make this more efficient, are we doing it right where we can trust it? It's really important for us to take the time to make sure it's right. Facial recognition software. Facial recognition software is very exciting. We all thought it was super cool when they rolled it out on our iPhones. We could open our phones, and we all love when you can do it. Take technology that's new and exciting, but for every way that you can use technology in a fun, exciting way, it can also be used in a way that could hurt people. People of color are already not treated fairly in the judicial system. A landmark study showed that 200 facial recognition algorithms had a harder time distinguishing non-white faces. These algorithms are used by law enforcement, border control, and is being integrated in many parts of the judicial system they're hoping to. Facial recognition software mislabeled 28% of Congress as criminals, and it was disproportionately affecting African American and Latino lawmakers. So we've already had a chatbot go racist and say anti-Semitic and racist things, and it took 24 hours for it to have to be taken off of Twitter. We've watched private contractors' algorithms that were built rate black people as higher risk for parole candidates. We've had the Google phone who couldn't even recognize darker skin. And we've had applications classify black people as gorillas. One of the most important parts of being any business and being in technology is earning trust. And if we rush innovation, we want to innovate fast, but not so fast that we lose trust of our customers and the people that we want to rely on our products. WHO, which is the Worldwide Health Organization, is already concerned about putting AI in medical diagnosis and different medical technology, which I think a lot of what AI promises would actually, if we do it right, really help people, because the more we can diagnose and the faster and more efficiently we can help people and get them into treatment, the better, right? But we already have such a distrust for our medical system. Look at how hard it was for us to get people vaccinated during COVID. And if we lose their trust, they won't get the care that they need. So it's extremely important for us to build trust there and to not just roll out things. So some examples of medical bias. Did you know that women die at a higher rate of heart disease than men? But it's because we have symptoms that are different. But for so long, we only studied men, so they were going untreated and unknown. So we were letting women die because of the way that we were diagnosing and recognizing that. Did you know that 69.9% per 1,000 live birth for black women die? So basically, black women have the highest maternal mortality rate. And I am one of those women. I almost died for 6 months after having my last son with preeclampsia. And I was like, I have to get out for my son's first day of school. And they were like, oh no. Like, which is different because Washington has really good medical. And if I was anywhere else and if I had just left, I would have literally died. My blood pressure was 170 over like 216, which is insane. Like, so this is like a real life problem. And if you look at just the history, especially with people of color and distrust of the medical system, if we further that distrust, we will leave people not getting the proper care that they need. Trust is very important in a relationship with people in the medical industry. So we've already talked about the problems. We've talked about how this can lead to the problems it can lead. But we all know that having a diverse workforce and a diverse perspectives help us to have less data bias, and it helps us to have better return on investment, make better software. So what can you do in your company or in your teams to make it better? We can start with having a more inclusive work culture. It's cool, hire women, hire people of color, but if you make them uncomfortable or you don't listen to them, or we're not having a place where people can work together and feel valued, what is the point of you doing the hiring initiatives, right? So mentoring and sponsoring, I think that's the first one that is one of the biggest things. If you see somebody that's new and they get hired, can you kind of have a buddy system with them and mentor them and help them learn? Maybe they are experienced engineers, but maybe they don't know your company's policies. Maybe they're more junior and you can help them get to that next level. I think mentoring is a huge thing for one. And also, people think of mentoring as a one-sided relationship. It's a two-sided relationship. Even if you're more senior, you're going to learn from the person that you're mentoring. It is a two-way relationship where you're both benefiting from the situation. So you may be helping that person, but you're also learning more. Especially as engineers, I think that the longer we do something, we forget how hard it is to start, right? Like, it's like when people write documentation. If you write documentation for something that you've been doing for forever, you may miss the things that maybe you need to like let somebody know when you're first starting out because you've been doing it for so long. When you get to mentor people that are more junior than you and that have a different background than you, you learn how to not only be a better teacher, but to be able to scale better. So you benefit just as much as the person that you're mentoring benefits. Career planning. Not everybody has the same goals as you do, right? Not everybody has the same track or, plan for their life that you do. So help them, but first ask them, like, what are your career goals? How can I be, like, of assistance in that way? Especially if you're a manager, good managers make a huge difference. People don't quit jobs, they quit managers, so it's really important to really, like, know the people that work for you, like, on a personal, like, you don't want to be nosy, but you know what I mean? Like, see them as people, right? And returnships and apprenticeships. I think that is, if you just look at my story, but I'll also tell you another story. So I have a really awesome friend. She's a brilliant engineer. And she also has, my son has autism, her son also has autism. So she's a mom of a special needs child. She had to drop out of technology for 14 years. And she had tried to go back to get a job again, and she has a great degree, great career, but she couldn't even find a job. And when she did, they made her an associate engineer after she had been a senior engineer for years. And if it wasn't for our apprenticeship, she made more as an apprentice as she did as an associate engineer. She was making 50% of our apprentice salary. That's like offensive. Like, that is ridiculous. So apprenticeships and returnships don't seem like a big deal, but it really makes me sad that that was one of the first things to get cut. We have gotten so many women back into the workforce through apprenticeships and returnships. I've seen it in real life affect people's lives and change people's lives. Also, a subject that not a lot of people talk about is when you give women financial stability, they can leave domestic violence situations. Like, it is so important to have like financial freedom. And I think people don't realize that. Not just that, but also we don't, like I said, we volunteer with a lot of military spouses. There are plenty of them who have husbands who end up like hurt and they can't work after that. So they become the primary breadwinner. So giving women financial freedom can affect their lives in numerous ways. Unbiased interview practices. Have you ever heard culture fit? Not everybody is going to be exactly the way you are, right? And that's what makes our teams better. We don't all have to be exactly the same. If you ask me Star Wars versus Star Trek, I'll have no idea what you're talking about, but I can talk to you about some other nerd stuff, right? So let people bring themselves to an interview and get to know them and what they're working on. Also, a lot of our interview processes in tech are very gatekeeping and biased, let's be honest. The way that we do interviews has nothing to do with what we do with our regular job. They're gatekeeping ways to keep people out of tech. And if you really want to hire good people, really look at your interview processes and how you are gauging candidates. Offer family-friendly work policies. This is going to seem crazy, but did you know giving men longer maternity leave actually helps women? Paternity leave? Because that means you're starting off and you're establishing better early caregiving habits earlier. So if a woman doesn't start doing all of the work and so if you give a woman 6 months of maternity leave and you give a man 6 weeks of paternity leave, you're already starting off with her doing more of the work at home, right? Did you know that the American economy is basically like profitable on the back of women doing the like labor at home? 67% of women are caregivers, right? So if you think about it, when you give men more family-friendly work policies, you're actually helping women too. So just having a family-friendly working environment really helps. Also, men in the audience, when you have to go pick up your kids, say that. You have no idea how much pressure it takes off of a woman being able to say, hey, I have to go pick up my kids, or I have to do this family thing, and not being the only person to have to say that. It really makes it that much more like digestible, and you don't feel like you're always the person having to like, have that thing. Making open source more inclusive and accessible. So it's really hard to get started in open source. It can be really intimidating. And I think sometimes when you've been doing it for longer, like if you go on social media or like Twitter or anything, there's always an argument about how to get like started and if like it's accessible. And then people are like, well, we shouldn't let certain people contribute because you need to be at this level. People are never going to be at a certain level if we don't let them try. It's like have you ever seen a job description that's entry level but they want 10 years of experience and you're like, dude, where? like how am I going to get that if you don't let me in and give me a chance, right? So I think it's kind of like, it goes back to remembering where we all started, right? And remembering that if we don't allow people in, especially open source, is to me the like best level of software engineering and just kind of making software, because everybody's working from all over for the common goal, and it's usually you're working for free. But how are you going to get a bunch of people to work for free if you don't let more people in? everybody that you onboard and help means less work for you. You know what I mean? So just really thinking about it and playing it forward in a way that you're making your life better and theirs at the same time, you know? Elevate women's voices. Have you ever been in a meeting and you realize one person keeps getting talked over and over and over again? I have said things in meetings, and I have this one friend, and he'll be like, "Hey, did you hear what Autumn just said?" And I'm like, like, over here, guys. So if you see somebody getting talked over constantly, or getting passed over for the cool project, or that woman's always taking notes in your meeting, sometimes if you say, "Hey, I'll take the notes," or "Did you hear what she just said?" or "That really cool idea that Autumn had just said beforehand," little things make a huge difference. And not only that, but when you make someone feel seen and heard, they're going to work harder. When somebody constantly goes to work and feels like their opinion's not valued, they're going to stop speaking up. They're going to stop contributing as much because they just feel like they're not being heard. So those little things are a big deal. Acknowledge the whole person and model bringing your whole self to work. So like I said about like, hey, I have to go pick up my kids at 3:30 and I'll be like unavailable. When a guy says that, it makes more room for when women have to do that too, you know? We're not just the only ones of like, oh, she always has to take off to like go pick up her kids. Life outside of work. You don't want to be like nosy, but you do want to like get kind of to know people, right? Like, hey, we both have cats, or we both really like, I don't know, anime, or, you know, like building that bridge and treating your coworkers like they're people and kind of getting to know each other on a people level really helps us to be like our like whole selves at work, which helps us to like, it helps you to, I don't know, just to feel like you belong, right? And that's really important. Thank you all for coming, and thank you for being open to the ideas. Are there any questions? Oh,
I'll come around with a microphone. That way the people streaming can hear.
I enjoyed your talk.
thank you.
You went into some detail about mentorships, but I wonder if you could expand on sponsorships.
Oh, okay, I love this. So I think sponsorships are something that not a lot of people talk about. The way that I explain it when I talk to like college kids and like people in early career is your sponsor is almost like your PR team in rooms that you don't have access to, right? So junior people are not going to be in the same meetings as people that are more senior, right? So just the fact of you knowing that person is already going to elevate them, right? Talking about them. If say there's a project and you're like, this person would be perfect for that project. They're really interested in this area. But if they're never in the meetings that talk about these projects or where those decisions are being made, if you mention their name, if you introduce them to people, like these things seem so small, but you'll be so surprised. Also, it's really interesting. So when you have a mentor relationship, it's a two-way relationship, right? Those two people are interacting. A sponsorship is like a three-way relationship. So you have the sponsor, you have the person that you're sponsoring, but then you have the audience that these people don't have access to. So it's a three-component relationship. And it's like, it's amazing. Just like sometimes people aren't the best at networking in technology, right? And when you can get them to people that like could be other mentors, because sometimes you have more than one mentor, right? Maybe it's someone that is in where you want to be in your career one day. Maybe you both have things in common, like we have like a veterans organization. So maybe they're both veterans, maybe they're moms, maybe they're just different aspects of your life. So even if you're connecting them to someone else that you think could help further them or help them feel like they belong, or, you know, it's really, I think sponsorship is not only underrated, but it's something that most people don't even know about, you know, and it can really bring a lot of value. I love your jacket, by the way.
Hi, I'm Chloe.
Nice to
Shear.
meet you.
You mentioned in your in your presentation, the sort of suggestions for existing companies to implement to create an inclusive culture. You also mentioned how the biases within the interview process and even after the interview process are both different from each other and between the different among the different genders, where the men have most of the privilege and everyone else kind of doesn't.
Yeah.
You also mentioned things about personal safety, and how some people are, rely on their income source to leave abuse, for instance.
It's really important.
So I fit into most of these categories here. And when looking for a job and interviewing, what are, at least in your experience, what are suggestions that you may have for someone to gauge an interviewing company?
Oh, I love this question.
For green flags, red flags, and yellow flags, etc.
Okay,
In
before
a way
I answer your
keeps
question,
you, like, presenting yourself,
I would love to relate this back to something else before I answer your question.
Please do.
So, when we look at diversity, like, people think this is like some warm and fuzzy feeling. It's not. This is not about warm and fuzzy. This is about you making more money and drawing good talent and making good software. There's nothing warm and fuzzy about this. When you attract more diverse teams, when I go and I look up your LinkedIn and I look up the people that work there, if I see only one type of people, I'm going to run for the hills, right? That is a green flag when I see that you've hired people that are different genders, that are different, or sexual orientations, that are different, like genders and colors of their skin. Like, when I see a rainbow of people, I'm like, this is my tribe. You know what I mean? So for one, I look at the diversity. I look if somebody is like, what is that one saying when people are like, this is a fast-paced environment, and I'm like, because I will work hard. Like, I took a data structured book into labor, and I talked to the PM at Microsoft, and she had to tell me to get off the phone and go have a baby. I will work so hard, but at the same time, I like hanging out with my kids and being a normal human, right? Like, that's okay. So I think you have to first think about, like, what's important to you. What is the life that you want to look for, that you want to have, right? And then you find a job that, within reason, is going to align with that. We all have to pay our bills. I'm a single mom of 3 kids, and my Costco bill is ridiculous. But I also want to see those kids, and I want to be at the house that I pay for at some point. So that balance, But I think this market is hard, right? Like, and sometimes we just have to do what we have to do. But I hope that if enough people that are in influential places can help us and see the value, then they can make for a better environment, So I think kind of at this point, we're hoping to get people that can make the right changes to listen, even though a lot of those slides have been said many, many times before. But hopefully we can see the value in them.
Hey, thanks for bringing this talk. You mentioned a couple different things in terms of like programs or organizations. And then also talked about kind of people, how they can step up. Is there anything in particular that you can point to that in general is more, in your experience and the people that you've worked with have had a greater impact? Is it generally individuals?
Yes.
Okay.
So there's 2 men on my team. I won't use any names, but they're my like ride or die besties, right? Like, one is like big and scary, and when people steal my meeting rooms, they just like stand behind me and interrupt people, and they're like, you're not listening to her. Like, dude, being yourself, being a person, being a friend, like on a human level is important. Not feeling alone, like anybody just doesn't want to feel alone. They don't want to feel like they show up to work every day to feel like they suck. Nobody wants to feel like that. Just being Justin is the reason I'm here. We're friends. We've met on Twitter. Now we have a podcast together. You know what I mean? Just being a nice human, like, that is so underrated. Like, help people. Just, if you see someone struggling, if you see someone always being talked over, if you see somebody that looks like they're constant, like, for instance, there's a girl at work, and she always sat by herself. And I was like, do you want to get lunch with me? You know what I mean? Like, just it's like, think about how we like it blew my mind during COVID. People were so mean to each other, and I was like, I'm gonna make you, as a mom of a little kid, I was like, I'm gonna make you all watch Daniel Tiger at this point. Like, sending you all back to Elmo, like like, which is like funny, but like, you know, like, it's like the basis parts of being a human that we forget. Just be kind to someone when they're having a hard time, because I think that like they'll teach you what they need, right? Like, we're all different. But getting to know someone, I can't tell you what the next woman will need because we're all different. But I guarantee you, if you befriend her and you make an effort, like, you know, I said, bringing your whole self to work, she'll tell you what she needs and how you can make it better, you know? So
Let's do one more question, and then I think we're at the end. But the speaker can always talk to y'all in the hall.
Okay, great. I'm the last question. Thank you so much for your talk. I really appreciated it, and it resonates with me.
thank you for coming.
I'm not in software at all. I'm actually a professor at
That's cool.
at Cal State LA, and so I see the other end of. So I'm seeing students, so the younger generations coming in, and I'm wondering what your kind of perspective and advice would be to kind of inspire and empower the younger generations to go into tech, because I see a lot of students being disengaged. A lot of them have been really impacted by COVID. A lot of them are dragging their feet coming to class. Some of them don't even go to class. So I'm wondering, how do we get that fire under them so that they're interested in you know, entering the tech world? Because I want them to be. I teach statistics, but I'm telling them, like, you know, data science is where it's at for a lot of jobs. But a lot of students, and specifically, as you mentioned, a lot of women of color. There's a lot of Latinas at Cal State LA, and a lot of them just think like they aren't good at coding, or like they just aren't good at math, so they can't do it.
I got a whole art degree because I was like, I'm not good at that stuff. Math is really hard. Math is really just instructions that you have to follow and processes. But you're told the whole time, math is too hard. Girls aren't good at math. And you're just like, oh, well, I'll just go get an art degree. That'll be better. You know? So I think we can start with representation, because we all do things based off of motivation, right? Like, we get up and go to work because they're going to pay you, right? Like, so if you put maybe some Latina or women of color, if you organize something, I'll zoom in, call me. Like, but I volunteer with like rewriting the code and talk to a lot of kids, and then I think it's really cool to build relationships and to kind of say like, hey, this is where you could be, and like doing workshops and kind of making them believe in themselves. But I think representation 100% matters. Like, seeing someone that looks like you, like, it gives you that like buy-in that you could be there one day. Which is why I always put my kids in my like talk, because people are always like, you can't be a mom and be an engineer at a big company. And I'm like, now I'm going to do it to spite you. Like, you know, like, so I think like telling people and like showing them like, hey, this could be you. I know it's going to be hard. You're not going to be perfect at it. Some days are going to suck. Like, you might get a D in a class. It's okay. Like, D's get degrees sometimes. You know what I mean? Like, and showing them that like, hey, like, yes, it's not going to be easy, but it'll be worth it, you know? I think that's the best thing. And I mean, I will find you people to talk. Actually, I know somebody. I know an engineer at Apple, and she's Latina, and she's badass. I got you. Like, she will definitely come talk. But I think that's the best way. Thank you guys so much. I didn't puke. Be proud of me. Does this mean I can get more coffee now? Huh? Thank you so much. I was so scared.
I know. It's wrong. No, I know. I saw this.
So nervous. Thank you for coming.
No, absolutely. I will connect to you on LinkedIn. I will lot to say to you. I will connect to you.
Oh, okay. I would love that. Thank you so much for coming to the talk.
What's the very beginning? Where are you geographically located?
Seattle. Oh, wait. I was getting like, I was going to take the mic with me.
green. Testing one. Testing one.
See if we can bend it a little more down.
Testing 1, 2. I'm going to try to walk around. So you've got that little changer, right? Is there,
I don't think we do have a
Oh.
remote changer. I think it's a,
there was one in here yesterday. Okay,
it might have been that speakers.
maybe. Okay,
I think this just turns the screen on and off.
okay.
So it's not this.
All right. I
So
can,
you might not be able to take any walks.
right. And walk around up here. Okay.
Here, let me see that thing. Let's see if we can get it. See what you think about that. I don't know if that's any better.
Oh, I think that's, now, will it project?
I think it's about as close to your mouth as it's going to get without
I-
putting it in there.
Little lunch.
You might just have to speak up a little.
Okay. We're all undergrads. Especially with this stuff. Debug.
How many of y'all, this is the first talk you made it to this morning? A couple of you did a little sleeping in, got caught in traffic, stopped for a coffee, maybe gas. How many of you, this is your first SCaLE?
Oh.
Oh, we have a few. How many of you are SoCal local? Big group. Who thinks that they traveled the farthest to be here? Where from? Shout it out. That's the farthest? 10 minutes away? No. All right, go for it. All right, south of Fresno, that's what, 3 hours, 4 hours?
Texas.
Texas? Anybody beat Texas? We got somebody from DC. We had somebody from France in the last talk. All right, looks like DC is the farthest traveler we've got in this session. We got about 5 minutes till start.
Okay. Actually, we don't have a class yet on this. No, I know. I mean, it kind of fits with natural language processing, the NLP stuff, but it's gone beyond that. So all the stuff that was valid like 3 years ago,
Right, but with the NLP, at least
you can connect to it.
you can sort of spit out the tree, right? But these don't spit out the tree, right?
Right, there's no tree.
So how do you even know how, you know?
Well, I hope maybe to shed some light on that.
Crazy stuff.
It is crazy stuff.
All the weirdness of it, like, you know, you're basically enshrining all those weird metaphors that nobody will remember the origin of at some point, but will be stuck in these LLMs, like just swirling around.
It's swirling around in multi-dimensional space. That's where it lives.
People need to start using like Cockney rhyming slang just to piss these off.
It probably has some of that in it anyway.
Your mission in life is to confuse the LLM. Yeah. No, how do you break through it? Very satisfying to watch them go nuts. I don't know why people are so. Well, because right around the time that the ChatGPT, OpenAI, you know, really blew up, they published their voice to text interface for free also, right? Directly open source and GitHub. But that's like the enabling technology for this, and nobody really noticed that they published it. It's non-language specific. It's a multi-language open source project. If you have enough computing power, it'll take any language and convert it into chunk it.
Right, yeah.
And it's like, oh my God, that's like the front end of this.
Exactly.
2-minute warning until start. 2 minutes.
Countdown.
Okay, this is 12:30, SCaLE 21 Saturday, sunny Pasadena. We have How Open is Open? Transparency and Accountability in Open Source LLMs. We have Frank Coyle here, professor at Southern Methodist University, specializing in AI from all the way back in the 1980s also. So we should have some good perspective. Please give a warm welcome to Frank Coyle.
Okay, thank you very much. Glad to be here. I was outside a few minutes ago approaching SCaLE, and I saw huge crowds of people, and I thought, wow, this talk is going to be really popular. And it was the, what is the TV show is out there, and a lot of action. But I'm glad to be here, and I want to give you a perspective on large language models from an open source and open viewpoint. So I wanted to start off with a prologue. So I was thinking about, this standard large language models are taking over the world and are involved in all aspects of society. So I thought I'd have some fun, and I like to have fun if I can. And so I decided to ask DALL-E, which is the generative AI. I said, draw me asking for an illustration of how large language models are being used in all aspects of modern society. And you see what DALL-E does. It has trouble with spelling, but there I am asking my question in some space. And here is what DALL-E thinks is the answer. Kind of freaky looking. If you're afraid of large language models, this might make you afraid. But it's got some of the dimensions. But there's an aspect of this that I like that we'll look at later. Is we're in this three-dimensional space, and so there's this aspect of dimensionality that connects with large language models. So the reason, the driving force for me to make this talk and to come out here, I've been to a few SCaLEs before when it was in Los Angeles. And so there was an article I found that I think will be of interest to many of you, and I just wanted to share that with you. It's called Opening Up ChatGPT, Tracking Openness, Transparency, and Accountability. And I've got a link to the article itself. And here, just some quotes. The main contribution of this paper is to show that openness is differentiated and to offer scientific documentation of degrees of openness in this fast-moving field. So there's this concept of open source, but open source doesn't really capture what openness means in these large language models. And so what they did was they investigated a huge number of large language models and categorized them on various aspects of openness. And so this led me to think about how to put this talk together. And there's a really interesting graph that's in the article. It's hard to see a lot of the details, but they basically break down a whole host of large language models and talk about the openness of the code, of the data, of the weights. We'll talk about that. A whole variety of things, and they categorize them. The green is very open, yellow is marginally open, and then red is not very open at all. And you see ChatGPT is red. So there's a link to a website where they keep this updated. So you may want to take a look at that, and I've got a link to that toward the end of the talk also. So what I want to just have you kind of think about is what does open mean for large language models? I mean, we have the source code, and the source code is simply the algorithm for the neural network that creates these connections in multi-dimensional space. So we know about gradient descent. Gradient descent is the algorithm that the neural network uses. But the real question is, what aspects of the large language models pertain to openness as we want to think about it? So I've kind of broken this down into a few areas. And so what I want to do here is I want to take a shallow dive into the technological underpinnings of large language models. And again, I asked DALE for a shallow dive picture. So here's DALE giving me a shallow dive. Now, so they spell DALE, D-A-L-L-E, which is a takeoff on Salvador Dali, right, the surrealistic painter. So, a little backstory here. When I was an undergraduate at Fordham University, Salvador Dali came to New York City. And I was fortunate enough to be in the arena where he came to give a talk. And people waited an hour and a half before Salvador Dali arrived. The place was packed, waiting to see Salvador. Finally, Salvador Dali arrives as wearing this cape and jewels and carries a stick and comes in as a greetings. And so I'm not sure what he said. The only thing I remember was there was a question from the audience. They said, "Mr. Dali, what is your conception of heaven?" He said, "Oh, heaven. Heaven is mountains and mountains of camembert cheese." And I thought that was a very Salvador Dali-esque comment. So whenever I speak to Dali, I always kind of think of Salvador and that. So I want to take a sort of a shallow dive into the technology behind it, because I think it's going to be helpful for you all to understand what the components are and how each of those plays into the role of open. So what do we need to create a large language model? So of course I had to ask Dali, show me lots of data, truckloads of data. So here's this crazy illustration of a truck with lots of data. Okay, so we know we need data, and data is the driving force behind the success of these large language models. Okay, now what else do we need? Well, now we're looking at some of the technological underpinnings. So all this data, web pages, Wikipedia, all these articles which are fed into the large language model are basically broken down into tokens, little chunks of text. Typically they're words. So, and there's some variations on this, which we'll talk about later. But you take some words, cat, dog, happy, okay? And it takes those words and creates an embedding. An embedding is simply a vector of numbers. So every word becomes a vector of numbers. And we'll take a look at this in a minute. But here's an example. Now these, the first GPT vector took every token and turned it into 368 floating point numbers. And it depends on your large language model. Some have 768, some have 1024. Huge numbers of vectors, a huge size of the vector. But every word is one of these vectors. Okay, it's a lot of information. Then it takes these embeddings, and this becomes the input to the neural network, okay, that will provide a significant amount of information about the text that's being read. Okay, so we've got data, we've got tokenization, we've got the embeddings, the giant vectors, floating point numbers, and then we have the neural networks. Okay? So here is what an embedding looks like. So I like to think that the embeddings are really the secret sauce behind the large language models. These giant vectors of numbers. So take the word SCaLE, for example. Now this is a 100 element vector, a list of floating point numbers, okay? It's actually smaller than what's being used. So I just found this example just would fit on the screen. But you've got maybe 1,000 of these numbers for one token, for one word, okay? So what does the embedding capture? How do we need this much information to keep track of one word? Well, it, over time, learns the syntax of the word. Is this word a noun? Is it a verb? Is it an adjective? And it learns it by looking at examples of the text. It also learns the semantics. What does this word mean? What is the context of this word? So the word SCaLE, you walk outside the building, you see the big sign, SCaLE, we see it, we know that this is the conference. But a scale is also something you use to weigh objects, okay? It's a way to talk about measurement. So the embedding captures this information relative to the text. So when you ask it something about SCaLE in Pasadena, it will understand, in many cases, that it's not talking about something to weigh something, but about the conference. So it's able to distinguish the semantics. What also captures word co-occurrences. The basic job of the large language model is language, and it predicts the next word of your sentence. You ask it a question, and it starts to come up with the words that best answer that question and what other words go together in this context. It also understands relationships and analogies and can deal with hierarchical information. It basically builds these hierarchies of understanding. So if you're talking about SCaLE, it will know that in this context, SCaLE is a kind of conference, okay? Sort of higher, it's one of the conferences that occur in the world. So this is it's amazing. We don't really know how this actually happens under the hood. We know that it happens, and I think it surprised a lot of people when they started fooling around with this technology, and bingo, all of a sudden, things started happening. Now it does this by taking those vectors and feeding them into the neural network, to a neural network. Over time, we get text coming in, text coming in, text coming in, text coming in. And those embeddings get fine-tuned. They get modified. When the process begins, those embeddings, those vectors are random numbers, just random numbers with no meaning. And over time, those numbers become knowledge. Those numbers encode the syntax, the semantics, the relationships that are part of the text that's being fed in. And this is done by training with terabytes of data that are huge energy consumers, requires tremendous compute power to generate these embedding models. So here's an example, very simple example of how something like this works. So on the left side, you see our words, our tokens. There's an embedding vector. It's only 7 elements. Just expand this to 700, 1,000. And what's really crazy is that the vector is a representation of a multi-dimensional space. Okay? Now, we are humans, we live in 3 dimensions. Okay, we understand 3 dimensions. 4 dimensions, people say, oh, maybe time is the 4th dimension, okay. But we don't have a picture of 4 dimensions. But what is the picture of 1,000 dimensions? We cannot grasp what that really means. But this is where the action is happening, in this multi-dimensional space. These terms are being embedded, and so the way it works is, and so you can do something called dimensionality reduction. So you can take a 1,000-dimension space and collapse it into 2 dimensions. You lose some information, but basically what you're seeing here is that words like puppy, dog, and cat appear close together in this multi-dimensional space. Woman and man are closer in the multi-dimensional space than a puppy and a dog, okay? So terms that go together are close together. And that's essentially how that's how the large language models work. When you enter a query into a large language model, it tries to find things that are close to that query, the words that you use in the query. And again, it is a language generating machine. Okay, now, GPT-1 had an embedding vector which was 768. GPT-3 goes up to 4,096 floating point numbers for 1 token. Okay, and GPT-4, not revealed. OpenAI doesn't want to give the store away. Okay, not that it would help us to know the size of that vector, because the computational resources needed to do that are huge. And that's why, of course, the GPUs are so hot and so successful, and why NVIDIA is, conquering the stock market world with its prices. And by the way, over in the exhibit hall, they have this GPU-driven machine with 8 racks of GPUs. Go over and look at it. It weighs 250 pounds, and I'm not sure how much it sells for, several $1,000 at least from NVIDIA. But go have a look at it. It's at the Meta booth. So one of the things to think about when we think of openness, you've got these neural networks. We have the algorithms for the neural networks, but we don't know how they're organized. So if you know anything about neural networks, it's basically nodes that are interconnected, okay? Sort of modeled on the human brain, which has neurons that are interconnected. And so what they don't tell you is how many hidden layers. Hidden layers are the layers between the input and the final output, which determines the dimensionality of the space that the neural networks can live in. So how many hidden layers does a neural network have? That would be a useful information if you wanted to reproduce what the large language model does. What is the size of the layer? So not only the number of layers, but the number of neuron nodes that you can have in those layers is a complete variable. So there's a variety of standard algorithms, but then there are parameters that are fed, that are used by the neural network. Things like activation functions, optimization, and then there are things like dropout. So the problem that one of the downsides of a neural network is that it will learn so well, it will memorize all the information that comes in. It's like a student that just memorizes everything but doesn't understand anything. So there's this concept of dropout. So every once in a while you pull a neuron out to make it not learn specifically so it can generalize in some way. And we do know that GPT-4, as advertised, has 175 billion parameters. So when you look at these neural networks, they have these numbers after them. Million, billion. What does that mean? The parameters are the weights on the neural network. The weights that connect, let me back up here. Okay, yeah. So the weights are really numeric values on the lines that connect one neuron to another. So all the neurons in one layer are connected to all in the next, to the next, to the next. And so these are the weights. So when you hear the term parameters, that's what it means. It's the number of lines connecting the nodes of the neural network. Now, imagine trying to draw a neural network with 175 billion lines connecting the nodes. Just gives you an idea of how complex those neural networks are. And I can't wrap my head around 175 billion parameters. So, trying to summarize our dive here, in addition to the data being used, openness in terms of tokenization. So let me go back to that concept of taking text and breaking it up into individual tokens. It's easy to think of the tokens as words, but in these large language model algorithms, they're not always words. There can be parts of words. They could be fixed number of bytes. So what is the tokenization scheme? How does the large language model give you their tokenization scheme? Again, the scheme is going to affect the end product. Then there's the embedding. Each token is going to be mapped to a high dimensional vector. That's our embedding. What algorithm is used to do that embedding? And what is the size of the embedding? These variables are not fixed in any way, and so this is also part of what you may want to ask when you ask about the openness of your large language model. And then there's the neural network, which we just looked at, which is totally configurable in so many ways, and the design of the neural network is, for GPT, part of the hidden piece of information, how it will do what it does. The number of hidden layers, the number of nodes per layer. This is the information that you want if you want to have an open system in terms of the large language model. So, that ends our shallow dive. And it takes me a while. It takes me a while to get these pictures to be what I want. You know, had the guy going in, so I said, all right, give me a picture of the guy coming out of the water with, just show his head. And so I got this guy looked like a frog man coming out. No, I don't want a frog. I want nothing on your face, nothing on your head. And you have to be very specific. I don't want you to have anything on your head, no mask. I could not get it. The best I could do is have them with goggles. They just he wanted to give me, Dolly, just, you got to have something on your head when you're diving in the water. Okay. So I'm going to take a little shift in our conversation and talk about the recent European lawmakers passing the AI Act, the world's first comprehensive AI law. I'm not sure you may have heard of this, but it was a big development, and their basic focus was technology should be human-centric, not just technology for technology's sake. It was passed by the European Parliament. It is going to be confirmed, presumably, by the EU member states, and they divide applications into three categories, and the one that's probably most important to most folks are what they call high-risk applications, banking systems, food-related applications, things that are critical to the human race. And that if you're building these applications, there must be human supervision in the loop. You cannot have these things run autonomously. Also, there must be a right for people to question and ask about why these answers are coming up, why these decisions are being made. And that the data used to create the model must be published, because it's the data that determines what the output of these models are going to be. And the fines are pretty hefty, up to 35 million euros are possible. Now, you may ask, what's happening here? Where's our laws? Where's our control? Well, I asked Dale for a little help in describing this. So we have two forces at play here. The AI Alliance. AI Alliance is a consortium of companies teaming up with academia to promote open alternatives to open AI. And Meta is a huge player in this, and IBM, they were the founders of this. National Science Foundation has joined in. The Linux Foundation has joined in. Good news for the open source community. Hugging Face, which I'll talk about in a minute, a wonderful website, and over 50 companies. They invited Apple, Amazon, Google, and OpenAI, makers of ChatGPT. What did they say? No, we don't really want to be too open. We are concerned with safety. Safe development is what we want and what we need. So they created their alternative group, the Frontier Model Forum. And Dale had a little trouble spelling Frontier Model Forum, even though I put it in caps and quotes. Please call it Frontier Model, Frontier Made. But it did get AI Alliance correct, so that's good. So it's interesting, the distinction, open, well, the Frontier Model talks about safety, safe development, and laws to control safe development. I'm not sure what that is going to come out to be. Okay, so Hugging Face. How many of you are familiar with Hugging Face at all? Okay, all right, great. We got a lot of Hugging Faces here. So Hugging Face is considered by many the GitHub of machine learning. There's an extensive library of 300,000 models accessing a broad array of collections of data uploaded by the community. And it's a great site to visit. It's got spaces where users can create interactive browser demos. You can check out your machine learning models. You don't need to have a lot of technology. And it's big on open source and accessibility. Deployment tools, and you can get lists of variety of models they have cards. Give you the background of the data. You can get data sets. You can download models that have already been trained in natural language. It's a great resource. Now, what are the advantages of these open models? So here's some terminology you'll run into. The concept of fine-tuning. So fine-tuning means you download your model, and it has to be an open model so you can change the weights. You're basically going to be changing the weights of the neural network that has created these embeddings. You're basically modifying those vectors. So you download your model with the embeddings already created by training, okay? Then you can use your own domain data. So you don't have to give it to OpenAI. You can use your own data to update, continue to train the neural network on your data. So you can make it a little smarter about your data. The embeddings then can become tailored to your own use cases, and you get more accurate response. So One way to think of this is you're running your data locally on your machine, and you're using the large language model to write syntactically correct stuff back to you, okay? And you get more accurate responses. Now there's another option besides fine-tuning, and that is something called RAG, which is Retrieval Augmented Generation. So in this way, you don't change the weights of the model, but what you're really doing here is you're using the large language model for its language capabilities, and you're feeding it in the data that you want it to digest and answer questions about. Okay, so I actually use this a lot in my classes. So this is a very useful way. The first example is useful when you're speaking to the large language model. So for the text enclosed in triple quotes, give me 5 bullet points that I can use in a PowerPoint presentation. So let's say you have to do a presentation. You have 4, 5, 6 articles. You take these articles, feed them in as part of your query. Let the large language model know what is the data you wanted to digest and what is your question. If you don't separate that, sometimes not sure what's going to happen. So that's been very effective. My favorite saves me a huge amount of time, making multiple choice tests up, and it's really good at it. Okay, for the text enclosed in triple quotes, give me 10 multiple choice questions and put an asterisk next to the correct answer. And it really does a good job. It creates all reasonably sensible alternatives to the correct answer. Maybe out of 20 questions, I have to correct 1. You don't want to let it just loose, because then the students are on my case afterwards. So, and then do not hallucinate. That's a very useful term to use when you're asking a question. Do not hallucinate. If you don't know the answer, don't say anything or say, I don't know, and it will generally respond to that. So what is a hallucination? Okay, what is a hallucination? If you think of this multi-dimensional space we're kind of trying to visualize, hallucination is simply a choice that's the closest to whatever your question might be. But if the information is not in the multi-dimensional space, it'll give you something close. So if you go back to the slide, man, woman, the closest item might be dog. It's like, oh, my husband is not a dog. Well, because it's not completely hallucinating. It's simply finding the closest match that it can find. Okay. And if you use an API, if you programmatically go in and use the API, for example, for ChatGPT, you can specify, I want to see the 5 top alternatives, and then it gives you a probability of correctness score, so you can see how close things are. Now, when you do the straight interface on the web, it will give you its maximum. But if you do the API, you can say, I want to see the top 5, and you can then look at them and see maybe something that might be more relevant. Okay. So I came to SCaLE on Thursday, and I was fortunate enough, this is a little postscript to our talk, to the Zoom by Bruce Schneier at the Kauai conference. And if you'd been there, it was absolutely fabulous. So I just wanted to give you a little background. If you don't know Bruce Schneier, he's one of my heroes. So I just wrote some stuff down at the talk. And this is from Bruce. LLMs are not your friend. They may sound really friendly and chatty, but they're not your friend. They are just algorithms. And the problem is that their language is seductive. They sound like us, and as he points out, we tend to trust those who sound like us. Somebody from New York, I'm from New York. You hear somebody from New York, there's immediately a connection. Somebody from Texas, whatever. Wherever you're from, a dialect, how you doing? Yeah, you're my pal, right? So I think that was an interesting takeaway. The other point, they act as our agents, but they're double agents. They're going to help you, but they're also created by a company whose objective is to make money, and their ultimate goal is to make money. They'll help you. I mean, they're not making money when I'm asking for multiple choice questions, but they do have their own agenda. If you don't know about Bruce Schneier's monthly newsletter, subscribe. It's free. Once a month, he sends his newsletter out via email, and it has really great stuff. It's called Cryptogram. His original work is in security. He was one of the developers of Blowfish, which was one of the major encryption algorithms. And now he's migrating from the world, well, not migrating, but the world of security and AI and large language models are now becoming, in a way, part of the same deal. So this is from his most recent newsletter. And it's called Microsoft is Spying on Users of AI. It's like, Microsoft announced that it caught Chinese, Russian, and Iranian hackers using its AI tools, presumably coding tools, to improve their hacking ability. So that was the announcement. In collaboration with OpenAI, we're sharing threat intelligence, showing detected state-affiliated adversaries tracked as Forest Blizzard, Emerald Sleet, Crimson Sandstorm, and all these wild groups doing cyber operations. As Bruce says, the only way Microsoft OpenAI would know this is by spying on chatbot sessions. I'm sure the terms of service, if I bother to even read them, gives them that permission. And of course, it's no surprise that Microsoft and OpenAI and everyone else are spying on our usage of AI, but this confirms it. Microsoft lets us know. So this is the reference to the article that I presented at the beginning, opening up ChatGPT. It's from the ACM, and there's a link to the website on GitHub. Look at their latest stuff. And from Dale, that's all, folks. Any questions? And if you would like a copy of my slides, there's a QR code that'll take you to the website. And
If you have questions, I'll bring the microphone around so people
Happy to.
streaming will be able to hear.
answer questions.
I have a question with respect to the openness of different stages of these models, right? Especially, can we go back to the time when we pre-trained the models? We are talking about fine-tuning. Much of these models were open-sourced, pre-trained by bigger companies. The question I have is, how much of Hugging Face is truly open? Because the pre-trained is given to us open source. How do you validate what's redacted from it? Nobody can look into these models to figure out what's in there. So we start at a wrong point, and we are heading towards even more. We are trying to correct it, but will we be able to absolutely correct it?
Yeah, no, that's an excellent question, right? Because these models that have been pre-trained, they've absorbed that data, and underlying, and you can't go back. You can't open up the door and right. So it made these right. So it's open, but there's that factor. And maybe the only way is to take the data sets that Hugging Face has and use the data sets, look at them, and then use those to build your own large language model, which is expensive. But for certain applications, one could imagine that if restricted domains, banking, telecommunication, healthcare, that you could, if you have the money, you could do it. Yeah, right.
We had a
You're
question
right.
back.
Yeah. My question is regarding, in your slide you showed ChatGPT-3 use 175 billion parameters. The GPT-4 is using trillion parameters. So if we take one parameter, in the floating point 16 representation, 2 bytes for the parameters, 2 bytes for the gradient, and around 12 bytes for optimizer. So each parameter will take around 16 gigabytes. So 1 billion is around 16 gigabytes of memory. But if you have to use for 175, you are looking at terabytes and petabytes of data. So most of the people in academics, we are priced out. We can't do GPT for like work anymore. I mean, machine learning, we could afford to do it with the supervised learning, with the generative AI. Just because of the computing power, you need hundreds of NVIDIA A100 to distribute the memory and compute it. So how can academics people do anything in this area? That's my question.
Yeah, well, I think yes. How can I think to paraphrase your question, how can academics even come close to building these models, given the limited resources that they have? And I guess, and again, it depends on money. And so, for example, at SMU, we have a high-performance mainframe computer. And some work could be done with these, and maybe the answer is going to be with the consortiums of academia and Meta and IBM and some of the big players to get together and try to develop their own models like this. But it's very difficult for an isolated university to compete in any way with this. No, you're right. It's an issue.
Thank you. That was a really informative talk. I kind of got struck by something that you said in the early part, and then later we saw the Microsoft AI, OpenAI collaboration there, and why wouldn't they? That's functionally the same company now. They had to use their own technology to mine the chatbot sessions, and they did this for a good reason. Earlier we talked about how wonderful it is that the EU is insisting that there be human supervision of these models. And I guess my question, or because maybe there is no answer, but how can we hope on the scale of petabytes that we just were discussing, how can we hope to actually supervise the actions of these models when the models are so huge they're, you said yourself, beyond human comprehension?
Yeah, where is the human going to fit in that loop? Yeah. But at least they're saying, just don't let them run completely amok. Have somebody taking a look, asking the questions. Right, it may be a fool's errand, but at least they're trying to get a handle on it. Yeah.
Okay, no feedback? Okay. So, fantastic talk, thank you. And what the question I've got is around, so the open source initiative has been working on the open source AI definition, and including the breakdowns of what you're describing, like which components need to be open for it to be considered open source or open by nature, right? But when I talk to people about the need for these models to be open and so forth, to be truly open, not open, fake open, the pushback I get is, well, the limitation is, I'm never going to be so big that whatever limitation on the license that the llama model has is going to catch me, that it doesn't matter to me, right? They don't see that there's a problem with it not being open. And I'm having some difficulty articulating what are the real risks of, like, what's going to happen in the future that you can't undo because you are working with a non-open something. Not that you'll have to maybe pay more money, but there might be bugs or security things. I mean, I can think about it from a software perspective, but I'm having a hard time articulating, like, what are the real risks of not being open in the future if you're trying to do something open source like, but you're using non-open models.
Yeah, so you're asking what can be done with an open source model in terms of ensuring security and fairness and so forth. Yeah. You make a good point. There are, terabytes of data. You're going to go through the data and try to find the points that are discriminatory or biased. And when you think about bias and discrimination, it just means we have more data that says X than we need more data to balance the bias. I'm not sure I have the answer to that question, but at least people would be taking a look at it. At least there'll be the possibility of writing software to mine the data in some way if we have access to it. But if we have no access to it, it's just a black hole, a black box.
Yeah, hi, Kai Pham. Thank you for the presentation. It's very clear. I just have a different interpretation of it. I'm working on reasoning AI. The first one is, Alan Turing is an amazing person, exceptional. His test is misleading because what looked like the same doesn't mean it's the same. And large language model looks like the same that human we are reasoning, but it doesn't. And we should call that large words association system, but there is no language in it because it doesn't understand grammar. It doesn't, even though if you ask it, it's going to answer you, it looks like it understands grammar because it goes to the text that explains grammar, but it doesn't understand grammar as we understand grammar. And then if you work at the knowledge level, you solve a lot of this problem. One is the computational, because knowledge is the most powerful way to compress data. Human, we do not process data. Second, in terms of understandability and trust, you can trust somebody if this person can explain what's going on based on the concept. The system here doesn't explain on how it gets there, it just makes association. And finally, have you noticed that any picture we see that generated from AI looks the same? We can recognize that in a second. Why? Because it's based on the statistical distribution. So it's not just that it's a double agent, but don't think that this thing understands anything.
Right, I mean, there's no, it's so different from the early days of AI and expert systems where you had rules and you could encode knowledge in some way. Here, this is just a word machine, but one that lives in this multidimensional space that does things we have no idea how it works. I guess one of the analogies that I like to think about is in the AI world of games and training using a neural network, example, to play chess and Go. So if you know the history of Go, and Lee Sedol, the world's champion Go player, played against the machine, and the machine beat him, making moves that no Go master had ever even imagined. And the same is happening with chess. So you let one of these neural networks, chess machines, loose, top players, it will defeat the top players, making moves and sacrifices that no chess master would make, yet it's operating in this other dimensional world where it sees things that we have no idea and no explanations for. And I think the same thing may be happening in the large language model. You're living in this space that we cannot even, I can't even picture 5 dimensions, more or less, 4,096 dimensions. But yes. All right.
We can, do you want to take a few more questions, or do we want to do hallway questions, or how are you feeling?
I'm feeling okay. If anybody have another question, happy to.
We got a question over here.
I'll try to be quick. I don't think that's even possible. All right, so when it comes to the regulatory part, we know regulations for the most part are constraints, constraints of what you can do. Where is the injection point for a constraint or some kind of limitation in the world of LLMs? Because are you trying to put it in when the actual training is occurring? Are you trying to put it in the tokenization part? Are you trying to put it into the neural network part? How does one work when the model itself is designed to be creative and hallucinate, when regulations as a counterpoint are trying to be constricting? So where does that fit, I guess?
Yeah, do not hallucinate. Maybe that's the closest we can come. If you don't know the answer, if you can't give me an accuracy of 0.9 or more, then don't answer the question. Don't give me an answer and lead me down a path. But again, you get probabilistic here, and it's tricky. There's no answer. I have no answer. We got one more question here, and then I'm happy to chat out in the hall.
So as all of these tools are used to generate more and more data, and what happens when the tools are trained with their own data? So the internet is becoming images and text, and everything is AI generated. What happens? How do you counter that by training your models with actual data generated from the models?
Yeah, the whole generative AI thing is you can create variations of text, variations of a painting, and feed it back in, and there's no way to prevent that. So I don't know the answer to that, but there's a related development in the video generation world. I think it's I'm blocking on the name of Sora. Okay, and there was an article that Sora okay, how did Sora get so good at making these videos? And one of the answers might be that it was using, what's the video game that has very realistic?
The video game Cyberpunk?
No, the video game where you can say, I want a video of an apocalyptic world with individuals.
Sims. No,
But
just
it was using this to generate images, generate movies, and then feeding and training Sora with those generative AI images. So maybe it can work both ways. I don't know. One more question.
What are your thoughts on the topic of the problem of forgetting things with LLMs? Once you open or not, once you transform data into these weights, these systems don't forget. There's no way to redact anything once it's in the model itself. And now that we are at this phase where GDPR is here, and then we unleash this thing where it will never forget, waiting for you to prompt it to recall in a special way. What are your thoughts?
Can you just repeat the question for the streamers?
Yeah, so I believe the question is how do you handle the fact that these models don't forget? Okay. So they don't forget, but what does that mean? It means that their weights are set to give you certain answers. And maybe the answer is you can feed it additional information to maybe offset, and their remembrance is a little fuzzy. Like our memory may be a little fuzzy from what happened to us this time last year because of all the other data coming in. That's not a great answer, but that's the best I can come up with. Yeah. Because in fine-tuning, what you're really doing in fine-tuning is you're giving it additional information to change those weights. And the bigger the model, the harder it is to fine-tune it. For a smaller model, you can more easily push it in the direction that you want.
So in effect, yeah, we are working with the system. Whatever we feed it, it stays there. Because I did this where I went to chat OpenAI and said, forget all my training data. I can't.
Right.
From now on, I'll forget, but not before. Last year's data is set in stone.
Yeah, it's in there.
It's in there.
It's in that embedding. And all you can do is push those numbers in some direction.
One last question, and then I think we're at our
We'll get ready
time.
for the next person.
Hi, great talk. Thank you so much. My question is, open source generally helped more open source projects because there was sharing of knowledge. So open source models, since what you're saying is they basically, the secret sauce is the data they're trained on. So is there a way to have the scientific community or the education community share the data sets? Or I know there's data sets in Hugging Face. Is that the answer to allowing open source models to learn from each other and sharing knowledge so that we can progress?
Yeah, I think it might be. In fact, there are some frameworks that involve agents, like AutoGen is one of them, where you can have agents working together in a collaborative way, and those agents could be connected to other large language models that have certain data sets, and maybe that way you get more collaboration and more bringing in other groups to collaborate in some way. The best I can say in a very mysterious world that we live in.
Round of applause, please, for Frank.
Okay. Thanks very much.
I'm sure he's happy to talk more on the floor, in the hallway. We've got lunch for an hour.
Yeah, okay.
Or maybe not.
How you doing?
One of the best presentation of how it works.
Oh, thank you.
No, seriously, I have a different view on how it does really, but the way it works.
Well, I heard your talk the other day.
Just narrative.
Well, thank you very much. Oh, thank you. Oh, can you can you unplug me?
I was just thinking, you know, and I'm kind of like piggybacking on what you said, but for example, even if you could point down to like asking a grammar question, for example, even if you can find where to check the GPT, even if you can find where it read it, you know, like where it got the information, like would it still mean that it doesn't understand it?
It doesn't really that's crazy. It doesn't understand.
But it doesn't, like for
But
example,
it may.
like if you ask me a grammar question, I'm going to be paraphrasing a textbook too, you know, because I didn't invent grammar.
Right.
I am paraphrasing too other people.
Right. It's based on your experiences
Yeah.
and your digesting, and our brain is made for language and to understand language.
Yeah, I don't know. Like, have you ever asked ChatGPT, like, well, create a new verb and like use it in a sentence and conjugate it? What it says, and if it does it correctly, it might be understanding grammar then, right?
Well, it would probably understand conjugation.
But then what it is about grammar that it doesn't understand, or what are we saying there? And I said immersion, like immersion phase. And I never correct my word.
Everybody get something to eat? Anybody ready for a nap? All right, let's try to stay awake for 1 hour. Do we have any first timers? Oh, pretty good number of first timers. What about SoCal locals? Who thinks they've traveled the farthest to be here today? Shout it out. From where? Panama. All right, you got that beat? Oh, we'll have to get out a globe and... All right. Poland, Panama, we had one from France 2 talks ago. The one in between, the farthest, was Washington, D.C. Okay.
How does the mic sound? Can you hear me? Is it close enough? Should I be closer? Closer. Okay. Up close and personal. I might take it out and hold it when I'm doing my bit. And then you can use that, but you can use this for the demo.
2-minute warning.
While we're waiting for our 2 minutes, audience quizzes. How many of you are familiar with the Chaos Project already? Okay, a few. How many of you are here more because you're into data science? Okay. How many of you actively contribute to open source projects? Okay. How many of you use something to measure the health of your open source projects? Okay. Cool. I think you're in the right place. This is good. Awesome. Thanks, everybody, for coming to our talk. I am technical difficulties. All right, there we go. All right, so I'm Dawn Foster. I'm Director of Data Science for the Chaos Project. I've been doing this open source thing for 20 plus years, so a really long time. I've worked at companies like Intel and VMware doing open source. I also have some other roles outside of the Chaos Project. So I'm co-chair of the Contributor Strategy Technical Advisory Group under the CNCF, and I'm also a board member of Open UK. And I'm also on the board of the Chaos Project.
Hi, I'm Callie Dolphy. I'm a senior data scientist at Red Hat, and I work in the open source program office, and I lead a project in there that focuses around doing data science on open source communities. Big surprise.
Awesome. All right. So the data tsunami, one of the biggest challenges people have with data is that it can be overwhelming, right? Now, this is especially true when you're looking at metrics for open source projects, where all of the data is available to gather and analyze. So too often, I see people measuring what's easy to count, easy to understand, things like stars and forks, which don't really tell you much about the health of your open source project. Quite a few metrics tools, including the ones we have in the CHAOSS project, display what I affectionately call a wall of metrics. So these are pages and pages of visualizations that you can use to understand your open source project. And they're great, but they require you to know what you're looking at and know where to focus your energy to get the data that you need. So we have visualizations for dozens and dozens of metrics, and all of them can be super useful. But which ones you should focus on depend on what you want to achieve. Ideally, you should be looking at visualizations that help you find areas that you can improve or ways that you can measure what you're achieving, whether or not you're achieving your goals as a project. Within the CHAOSS project, we tend to look at metrics as being used for two primary purposes. Historically, CHAOSS has been a bit more focused on what I call contribution metrics, so the box at the top. And these metrics are designed to be used to better understand the projects that you're participating in. Whether these are open source projects or other projects, open source projects that you run, or maybe open source projects that you just contribute to. And we have a starter project health metrics model with a collection of 4 very simple metrics to help you get started measuring contribution. And we have a whole bunch of other metrics models on similar topics to help you dig in for more details. And lately, we've been also focusing on consumption metrics, which is the second type. So that's the box at the bottom. And these metrics are mostly related to inbound or downstream consumption of open source software. So the software that you use from within your projects, your products, maybe your infrastructure. And we have a starter viability metrics model with 6 metrics. So these are some models that Gary White at Verizon developed for us. I told him his starter project health metrics model had to have 4 metrics, and he made it 6. He just couldn't cut it down to 4. Everything was too important, which to be fair, it's kind of hard. But these are used to measure the viability of the open source projects that you consume. And Gary also developed 4 complete viability metrics models with a whole bunch of metrics that were developed recently to help you gather more information about the projects that you're consuming. And these collections of metrics are organized into metrics models, which can all be found at the link on the bottom of the slide to help you think about how you might implement a set of metrics together to understand some aspect of open source project health. But a big part of using data is figuring out what questions you have and how you can take this tsunami of data and figure out which metrics can help you turn it into something more meaningful. So in the next section, Callie is going to talk about how to do this using approaches from data science and what she's learned from building the 8-knot visualization interface for CHAOSS's Augur software. Take it away, Callie.
Awesome, thank you. So, let me. Let's just see. So, I'm first going to take this from like a general data science perspective. When people are talking about data science, you're going to see some version of a graph like this, or just showing what the workflow would be. It's always going to start with something around figuring out your problem space, finding your data, cleaning your data, doing the analysis, and whatever the reporting or deployment model would be. And so for us, when we think about open source data, why would we want to reinvent the wheel, literally, if you talk about the second graph over there? every time we want to ask a new question about our communities. It's very time intensive and really starts to slow down that process and limits what your capabilities are around the analysis that you do on your communities. When you start to cut down that time, that's whenever you can start to evolve and make your visualizations a lot more complex and specific to the communities that you're looking at. So, first, let's talk about this more at a conceptual level, putting the data aside for a second. First, you have to start thinking about what is your specific problem or problem space that you want for your community. Many times people come to me and just say, I want to do the data thing. Give me general metrics about your community. And that can honestly be a pretty frustrating place to start from because I don't really know what to give. But I also understand why that is the first spot. You have to kind of figure out where you want to start and go from. That's why I really think the starter metrics model that's been set up is a really nice entryway because data can be so overwhelming. What do you do with the millions of rows and columns and all the different points and trying to figure out where to start? And so that's a good generic starting point, but then you want to start going in a little bit more about what you want to learn about your community and start going down that path. And I'll say that as a data scientist working in the community data analysis space for over 4 years, once that technical architecture is there, the difficulty lies so much more on the concept building around your visualizations. And even if somebody's technical setup is much different than yours, you can really start to collaborate on the concept side of it and start to make things that are really interesting. That's something that I really like about the chaos community is that there is a really large span of tools that people use, but we can all come together to be able to talk about what we want to look at, what data, and what questions we want to ask, and that makes all of our analysis better. So, once you start getting that initial question or metric, then you can start converting that question to a metric. And the first thing that I personally like to do whenever I start to ask a question is look at the research on the established metrics already. And that's what Chaos kind of does really well is gathering all the different metrics that people have talked about. There's a whole metrics model groups that has done pages and pages. And so once you have that question, those pages of resources go from being overwhelming to being incredibly useful. And that's why you kind of have to start down that path yourself, because even though those pages of information can be helpful, it can also be very overwhelming. And so once you kind of get a pointed start, it starts making it a lot easier to go along this path. And so from there, you want to start looking at the specific data points that you need. This is where your data engineering or your technical architecture is going to determine whether those data points are available. Have you set yourself up for a really general case? So even though this might be an analysis space that you haven't looked at before, are you set up for it? Or is this something that you need to establish, start looking at the data, collecting, storing, and cleaning it? And so that will be your next step. Then you would like to go into how you want to visualize and represent that data, and then go into what potential insights and actions. And this is really the first stop on your visualization building process for your communities. Once you have that first work in progress metric, that's when you want to go over and start getting your community feedback. With all of these metrics and research from the Chaos community and others, you get a good starting point, but that doesn't take in the unique qualities of your own community. And people within your community are going to have some knowledge that you might not have either. There might be some type of anomaly, and there was some event that you didn't know about, and somebody else that was working in documentation does, and they're going to flag that off for you. But that is going to be the process that really starts to fine-tune what visualization you make and making it very useful for your community. I'd say very rarely does one exact fit, once you start getting to more specialized metrics, work for two different communities, especially if you're looking at communities of different sizes. Let's see. So now that we've talked about things from more of a conceptual standpoint, let's look at this from a data standpoint. I would say very rarely are you going to need a single data or metric point about your community. I would say I've not really seen that scenario too much within a community where it's like, this is the one thing we want to know and then nothing else. And I would say a lot of times you would very rarely end with that same question that you started with, even in this hypothetical scenario that you want to learn that one thing. By setting up for a more general case from a specific data source, every question that you do, every visualization you make, next, we'll take out the first 2 or 3 of these steps in the data visualization, or pretty much the data science workflow. You already have established getting your data, storing it, structuring and cleaning it, and you can now start looking at making your visualization, hosting it. A lot of that architecture and background is set if you are prepared in the beginning for the most general use case. And I would say gearing your tooling or your setup to one specific question can really limit you and your community and be very time costly in the long run. I can say I worked with a community that built a really large tech stack around one very specific question around a community. And then they came back to me and wanting to do even just a minor pivot off of that. And I had to tell them that the way that they had set up their architecture didn't allow for that type of pivot. And so they had to go and set everything up all over again and find a new solution to be even able to answer a question, for example, instead of just looking at the total number of contributors, but seeing how frequent different contributors are contributing. And so whenever you get too honed in and not looking at what all is available from a data source like GitHub, it can cost you big time in the long run. And I would say as you go through as well, once you learn more about your problem space, which in this case is your community's data, and start working with the data a lot more, which in the data science world many times is called EDA, exploratory data analysis, you're going to start pivoting more and more through that process. And you'll be able to get a visualization or metric that's so much more useful than that idea that you came in right in the beginning. So these are some of your common open source community data sources. I'm curious to see, does anybody in here take data from some of these sources for their communities? I'd be curious. With that, are y'all doing like JSON dumps? How do you get this data? Just pulling straight from the API? Anybody can call API? API, everyone API? Okay. Shocker. That's what this next slide's going to be about. Whenever you're looking at those common data sources, the retrieval method is almost always going to be an API. And with those outputs being in a JSON or CVS form or CSV format. And this isn't unique to community data. This is pretty common across all data sources online. And I would say in the cases when you're not getting it from an API, maybe getting it from a direct download or scrape, that end product is still going to be a JSON or CSV. And beyond a one-time use case, having data in a JSON or CSV can get complicated really quick. I have a feeling that at least one person in this room has a file in their computer titled data_dump135. And you don't really know if that was the one from this week or last week. And that just starts to get really complicated really quick if you're trying to even do the same visualization twice a month later. That means you have to collect your data again, store it in another file, then you have another file in a folder that you might mix up, and it just gets complicated and storage-wise very dense quickly. And a full workflow cannot be based off of a fragment, and that's what a lot of times those one use cases are. So. And many times, in the data science world in general, a relational database is the tried and true method to store your data for repeated use. Which database you choose to use for your specific use case or preference doesn't really matter. It's more of that relational structure of your data and that structure being very consistent. A relational database, in our case, among many other things, allows for mapping between different types of contribution types and the contributors that performed them. The data is cleaned and it can be used in a reusable format. I mean, you're able to, whenever you have that structured data, looking at issues and PRs and commits and how the same exact contributors are contributing in all those different fields, you're able to do that if you're trying to look at that from a JSON file, trying to bring all of that information in and transform it into a similar format. That's something that you have to do every single time, whenever having that relational format does that for you. And so whenever you're setting up your data collection for that general use case, you have all of the data in that specific case. I'm going to talk a lot about GitHub here. The structure is clean and consistent, and there's a lot of visualization tools that are set up to plug and play to a relational database. You can think about Grafana, Superset, that data that is in there. You can start to make those high-level visualizations right off the bat, and you don't have to invest in deep levels of code or pre-processing to make those initial sets of visualization. And you can also start to evolve your analysis much quicker because of that ability to pivot. And another portion of this is that data structure, when it being standardized, it allows the pre-processing of the data to be able to be reused across many different visualizations. Each time you analyze something, the next time you want to do it in the exact same way, it takes little to no time investment. And if you want to do something that's vaguely similar, it takes a fraction of the time that it did with the first iteration. Obviously, if it's more similar, it's going to take less time, less similar, more time. And there's kind of two different ways I like to think about this, and we're actually going to get to see some of these visualizations in a second. One of those things is a structural similarity. I like to kind of think about it from a puzzle piece, is that the structure is all there. We just have one portion of that puzzle that is being taken out, and it works the same way. We can think about this from the time to first response for issues and PRs. We can look at it, pre-process the data the same exact way to see that first response, and whether that is issues or PRs, it's very little difference. Another example of this is looking at the staleness, which is how long has it been since an issue has been open versus it being closed or merged. How long has it been staying in that pending category? Whether that is issues or PRs, there's a very minimal switch. It's really just closed and merged as an additional option, but even with that, whenever you look at the data, if a PR is merged, it's still counted as closed. And then another way to look at this is the data similarity. And so many times you can take the structure of the pre-processing you've done for a similar data type, move it around a little bit, and get a completely different view on the community that you're looking at. One example of this is looking at PR review assignments per contributor or status counts. And again, we'll kind of look at this example in a second, but the idea here is that some people want to know how many PRs are being assigned to specific contributors. Is there contributors that are being incredibly overloaded with that responsibility versus others, and wanting to see how that responsibility is distributed over time? And maybe there's a case where you just want to know in the aggregate, is my community assigning PRs or is it not? Is it assigning issues or it's not? And in some cases that might not really apply to your community, but this is one of those data similarity standpoints. Another one is looking at flyby contributors versus repeat contributors. So you would want to maybe look at what are the type of contributions that are done by people who maybe only do 4 or 5 contributions and then leave the community, or what are the people who are staying in that community for a consistent and long period of time? What does their contribution activity and types look like? Even though those are looking at the inverse of each other, the data processing in the code is very similar. So how does this look like in action? So I'm going to show, in my specific case, the tools that we use that fit under this framework. But there are many tools that fit under this framework. It's kind of just the idea here. And so for our case, whenever we look at the database, we use a project under the Chaos project that is called Augur. And it takes the mountains of data that comes from GitHub. If you've ever worked with the GitHub API, you know pain. And they have done a lot of pre-processing and structuring that data in a large Postgres database. And so I'm able to, as a data scientist, just go and do SQL queries, and I get structured data that is cleaned, and I can see things across many different contribution types and see what their contributors are and doing across the different repositories. And that's not even just within one repository. I can see if a contributor, what their activity is among all of the repositories that I collect on. And so having that structure, having the data engineering, and having validated data makes my job as a data scientist so much easier, because I can focus on my analysis, not on making sure that collecting my data, cleaning it, because that's a huge undertaking. And so if we're going to look at the high level architecture for Augur, the Postgres database, that's what I touch whenever I'm making my visualizations. The Augur tool is the one that communicates with GitHub's API and does direct pulls from just doing a Git clone to get a lot of this information. And they clean it, structure it, and put in that Postgres database. And from there, we have our 8-knot dashboard. So we take this structured Augur database, it's a relational database with the Git platform data, with enforced data validation. So all of those things I can know to be true. And then built on top of this is a dashboard that we based in using Dashplotly, which those are packages in Python. We really wanted to use the Python tool set because we knew I really wanted to capitalize on the 20+ years of data science research and backing that has gone into the packages in Python. And we were able to do the pre-processing in Python and do the visualizations in Plotly with all of the data from Augur. So it's kind of that plug and play. If you've ever seen Grafana or Superset, you can kind of think about it the same way. We get those database credentials, we now have our dashboard, and we're able to make these visualizations. Sweet. Now we're going to do a little bit of a demo so you can see some of the visualizations I've been talking about. We did a workshop a couple days ago and I lost all the slides trying to switch over to the demo. So I'm no longer allowed to do that. Sweet. Thank you. So this is the 8-knot dashboard. You will be able to see a hosted version of this online. We'll have the link to this in our final slide. You can come and talk to us about it. This initial welcome page, if y'all do go and look at this a little bit more, there's a bunch of different tabs talking about how to use the dashboard, how to make user groups, which is a combination of a bunch of different repositories, how to get the database to start collecting on the repositories you care about. All that good stuff, all that information is right there for your use. But let's look at some of those visualizations that I was talking about. And this is also a really good example of what Don was talking about earlier of the wall of metrics. There's a whole lot of metrics here, and which ones do you care about looking at? If you haven't taken the step beforehand asking yourself what questions you want to ask, there's a whole lot of colors and bars, and they don't really mean very much until you start to get a little bit of a perspective of what you want to know. So one of those examples that we were talking about where you're kind of using similar data but changing around the code and the structure a bit, you have this pull request review assignment. So it's looking at the assignments by contributor versus the status count. And then whenever we're looking at two different, I don't like that. We're looking at the staleness of issues is very similar to the staleness of activities or the staleness of pull requests. And so those were a couple of the different graphs that we were talking about. What time is it? We have a little bit of time. I'll hop around a little bit. Another thing that people seem to really be interested in is the contributor affiliation. So where are your contributors contributing from? If you're able to identify if they're associated with any individual group or company, this is one of those things where you're able to take, I think about this as a general page, as a general question of what is the organizational diversity of my project. It would be great if you could just get a list out of numbers and how many people are individual contributors, how many people are for which company. We don't really have that data, but we can start to at that question from a lot of different angles to start to get a holistic view on the project's makeup. And so an example of this is that there's two different graphs right here, and one looks at the unique emails of all the contributors. So even if I contribute 1,000 times, my email counts once. If somebody contributes once, their email counts once. So that gives you one view, while the commit activity by domain, that's going to be proportional to the amount of activity that's in the repository. And so it's not going to tell you the full picture from either one, but you start to be able to get a more full view of your community when you start to look at things from different angles. So this is the app. I'll pass this over to Dawn, and if people have other questions or things they want to look at the end, we can do that as well.
Okay, cool. So I am going to show you a little bit about the starter project health metrics model. After I just let me reconfigure everything, and then we'll be good. Okay. Okay, perfect. Nope, almost perfect. Nope, it's this way. Okay, there we go. Now I've got the cursor on the screen that I'm looking at. These things are important. Okay, so Kelly talked a lot about gathering data. You've seen her demo of 8-Knot using Augur. But it's also important to do something useful with all of this data, right? So the data is great, but we talked earlier about the tsunami of data, and tools like Augur, 8-Knot, and other visualization tools, as we've both mentioned, don't actually solve this problem for you. You still need to think about what questions you have and what you want to learn about your project to help you focus, right? Focus on the data and the visualizations that you actually need to see. So in the case of open source project health metrics, I did create the starter project health metrics model with 4 very simple metrics that I mentioned on the earlier slide about chaos metrics models. So if you're still figuring out which questions to ask, you can use this data as a starting point to improve your project and your community. Now, not everybody needs this. If you're already experienced in metrics, you're already using it, then you probably don't need these at all. But they're a really, we found them to be a really helpful way for people who are just getting started. And I'll talk about a few ways to interpret this data so that you can use what you've learned to make actual real improvements. And then hopefully what you learn from these 4 metrics will generate new questions and new ideas for what additional data you might need for your project. I recommend measuring contributor sustainability using bus factor, which is also called the lottery factor, because it helps you understand what might happen to a project if one or more of the key people on your project won the lottery, retired on a beach, and very suddenly left your project with little to no notice and never came back. There are a couple of things this metric can tell you. First of all, how big of an issue is your current contributor situation? If it's like this one, you really should focus on getting a few more people who can contribute and eventually be moved into leadership roles like maintainers or reviewers, for example. Now, this graph shows the top 10 contributors to a project. And out of those top 10, these are the percentages of contributions. So you can see that there are 2 people who are responsible for quite a few of those contributions, but there are also quite a few other people who aren't that far behind them. So this one's looking pretty good. But one reason I really like this metric is that you often find that there are people who are contributing more than you realized. And this can help you think about who you can encourage to contribute more. And maybe find someone who could move into a leadership role. Reaching out to someone and acknowledging their work while encouraging them to do more can help quite a bit with growing your contributor base. Sometimes people just need a bit of encouragement, and you can ask them for specific things that you know that they're particularly good at. There are several communities that I've personally gotten more involved in because someone came to me and asked me for my help with something specific. And in this case, you might look at the people making fewer commits to decide maybe they're ready to become a maintainer. Or if not, maybe they're good candidates for becoming, for being mentored, for mentorship. Or becoming reviewers with an eye toward then making them maintainers after they get just a little more experience within the project. Now the catch here, and with many metrics, is that we don't just want to think about the people making commits and pull requests. It's a good start, right? But you should also be thinking about how you can move people into maintainership or other leadership positions to be responsible for things that might not show up in a repository, like documentation, community management, marketing, product management, all of the other things you need within your project that are really important roles for you to be successful. It's really important to keep up with requests and resolve them in a timely manner. Even if the response is closing requests that aren't going to be merged, which can be a difficult conversation, and it is very easy to get behind on incoming contributions. We all get behind sometimes, but not addressing these contributions promptly creates technical debt and reduces the chances that they'll ever be merged, because those old change requests or pull requests are likely to have so many merge conflicts that they're just going to be too difficult to accept after a certain point in time. Now, it can be tempting to solve problems with responsiveness by putting some extra pressure on the existing maintainers and asking them to respond more quickly and resolve more contributions. But this rarely actually solves the long-term problem. You might get some short-term gains, but it could be damaging to the community and the project over time if all you're doing is burning out your maintainers by not resolving the underlying problems that are causing the lack of responsiveness in the first place. If you see responsiveness declining, it might be time to move more contributors into leadership roles and promote some contributors to become maintainers for your project. As I mentioned on the contributor sustainability slides, you can start by looking at those contributors within your project to find people who are contributing regularly but maybe aren't already maintainers. And a good first step really is to promote some of those people to reviewer roles, where they can reduce some of the load on maintainers by reviewing contributions from other community members. More people reviewing contributions should provide better responsiveness, since maintainers will have less work to do for each contribution, and then they can focus on the things that require maybe more expertise within the project. It's also important for projects to respond to requests in a timely manner, because a quick response can help you retain contributors who otherwise might become discouraged if they just never get a response or get a response months later after they've forgotten that they even submitted a pull request. So timely, thoughtful, and kind responses to contributors indicate that you appreciate their work. In both of these responsiveness metrics, it's really important to focus on the trends. If responsiveness is already improving, great, keep up the good work. However, if you see responsiveness declining, then it might be time to find ways to improve it, including, as I mentioned earlier, recruiting more contributors and maintainers. But talk to your maintainers and find out what else they spend their time on. If maintainers spend a lot of time on things like community management, documentation, or other tasks, then maybe recruiting people to help in those roles would be time well spent to free up time for maintainers. In other cases, improved documentation might help reduce maintainer workload. For example, if maintainers are spending a ton of time onboarding contributors or answering questions about the contribution process, maybe better onboarding docs or contributing guides would free up some of their time to focus on responding to incoming contributions. It can also help to use templates for things like issues and merge requests or pull requests, since anything you can do to help contributors make good contributions that require less work from reviewers and maintainers can really help improve responsiveness. The other point I wanted to make on the slide is that there are a lot of different ways to visualize data using the Chaos Project's Augur tool. So in this case, I wanted to focus on the trends and display some additional explanatory data above and below the slide. So I created these visualizations by writing queries against Augur's Postgres database. So this is the exact same database that Kali uses in 8.0, which I use to collect the data. And then I just use standard Python libraries like matplotlib and Seaborn to actually just create the visualization. And again, this is a custom visualization, primarily because where an individual project releases varies quite a bit, depending on the type of project that it is. But regardless of where the releases can be found, it is really important to look at the frequency of releases, including all of the releases, even those little teeny point releases, because it's critical that security updates and bug fixes actually land in a release in a timely manner. And it's important to get those new features out as well. And an appropriate release frequency for your project is influenced by the size of your project, maybe how many dependencies you have on other projects that are also releasing fixes that you'll need to incorporate. For projects that you contribute to, you should think about whether you're cutting releases frequently enough to keep the project up to date and secure. Now the catch is that none of this is something that you get to do once and then just forget about. Regardless of what metrics you're using, you should be thinking about how to make this a continuous improvement process. So the starter project health metrics might be a good start, but you probably want to add a few more metrics later to better understand other aspects of your project. And then when you take action to make some improvements, you'll want to monitor those metrics over time to see if the actions are making a difference and to see if any improvements actually persist over time. Here is a link to, the top link is to the CHAOSS community where you can find our metrics, our meetings, our software, our podcasts, our blog posts, and all kinds of information about how you can participate in the CHAOSS project or just use the stuff that we create. That's cool too. The metrics with an X link is to a software as a service offering hosted by the CHAOSS project where you can use Augur and 8-Knot. You can add your own repositories as long as they're public, or view ones already added by other people. You can also have a look at the 8-Knot repo if you're interested in learning more about how they've created their visualizations, and you can contribute new ones. So it's fairly straightforward to build on the existing visualizations and create new ones that are similar, that meet your particular needs. And I've also added a link to an article called Beyond the Repository, which it's a short read. It's something like 6 pages. But it talks about some of the things you should be thinking about, like responsible use of data when gathering and analyzing data about open source projects. So it's something that I just kind of recommend to basically anyone doing research or open source metrics gathering. Now, throughout this whole presentation, we've talked about how the data for open source projects can just feel like a tsunami of never-ending, overwhelming amounts of data. Callie talked about how to use a data science workflow as part of your process for thinking about how you can use data to answer the questions you have about your project, along with how to gather your data and store it in a standardized data structure, like a database, for example, to give you the flexibility that you need to answer additional questions in the future so that you can reuse what you've already gathered to produce additional visualizations from that same data. You should also think about how you can build on the work that other people have already done, right? Like the metrics and software that we've developed for the CHAOSS project, for example. And you should work with your community to help understand what the data is telling you so that you can build a more rich interpretation that helps your project make improvements. But having the data and the visualizations is really the start of the journey. It's not the end. You need to understand what it all means for you and for your project by coming up with actionable insights and ways that you can improve your project as part of a cycle of monitoring the data to ensure that you're continuously improving and learning as your project evolves. With that, thank you, and we have plenty of time for questions.
So we're short on microphones. If you have a question, shout it loud, and then I'll just ask Callie and Don to please make sure you repeat it so the people streaming will be able to catch it on the mic.
Okay, go ahead. So what do we say about Goddard's law, which is once you make a metric public, it becomes a bad metric? Do you want to start with this, or do you want me to? You can say your opinion. Okay. Yes, anything that you measure will likely be gamed by someone. So one of the things that I've tried to do, so in particular when I was at VMware, I really tried, I used those 4 starter project health metrics with all of our projects because my thinking was that because these metrics really are about improving your project, that most of the things that they could do to make those numbers go up were probably good things. So I try to make it so that if they do try to game it, so that the numbers are better, that hopefully it will be done in a way that makes the project better. However, I've also seen it go terribly wrong because at a certain company that I worked at, one of the business units decided that they were going to take OKRs, so basically how they were going to measure the performance of their employees were based on my metrics and whether or not, because I had like a kind of a green-red scheme. And my response to that was, oh my gosh, please no, please don't do that. Because I've set random arbitrary thresholds that are what I think work for most of that company's projects, but they're not, there's no one-size-fits-all metric. Like they blatantly won't work well for certain projects, those thresholds. So what I talked them into was that they should make an improvement to something every single quarter or whatever it was, so that they could show that they made some improvement into their project. So it could be anything, and as long as they were improving something, then that was good.
Yeah, I have a couple thoughts. I'd say the first one is that this is why I like having multiple visualizations that's looking at like a similar space. If we look at the like affiliations page, for example, that has a couple of different visualizations that are all looking at similar things, I think that helps prevent the gamification problem, because once you're starting to shine the light in a couple of different angles, if they're all showing a positive trend, then I kind of go to what Dawn's saying, that it probably means something positive. I would also say is that once you start getting into a larger visualization portfolio, I think it's pretty hard to start like, I would dare someone to try to, I don't know if I want to dare, but being like, gamify all of the metrics on 8-Knot, sure, that'll take you a lot of time, but I think the quickest way to gamify them would be to just make improvements in your community. Yeah, I think everyone you ask in this space is going to say something a little bit different. And so I'm kind of glad that Dawn's here as well, because I think she's going to answer this very differently than I would. The initial thing that I would say is that if you're trying to look at those repositories in aggregate, if all of them grouped together is what really matters, then I would say, okay, then you can start looking and using like 8-Knot, and I'm too scared to touch it. And you can put in the search bar all of those repositories. That's when you could create a user group. And so you can start looking at all of those metrics in an aggregate way. And then if you're trying to, if it's all about the individual ones, then I would say that you would start to look at it more of an individualistic way. I think that one thing that's also really interesting is there's a project velocity graph that we have on 8-Knot that you can choose what the weights are for issues, PRs, and different actions of what matters the most. And you can see the velocity, which is something that you choose, of those repositories next to each other. You're looking at like activity for issues, PRs, and then it's the number of contributors is the size of like the dot, and then the axis, I think the other axis is commits. But looking at visualizations that will put them all in a comparative chart. So it's more matters of whether you need to see them as individuals or if you need to see them all together.
Yeah, and then just to add to that, those starter metrics are really just designed to get you thinking about what you need. What I actually recommend that projects do, or companies, if they're shepherding some open source projects, is to really take a step back and think about what your overall organization, so your project or your company, what they're trying to achieve, how the work that you're doing within that project fits into that broader structure, and then what metrics do you need to show that you're successful in whatever this criteria was. So this is what's going to be different for every single project. Like, you can start with some things to get you thinking about what your options are, but you really should, at some point, really take a step back and figure out what you need to achieve and how you can justify it. Because it's something, particularly in the the financial climate that we're in right now, right? Like, it's kind of hard. Like, companies are looking for things that they can cut, right? And you don't want to be that thing that gets cut. So if you can use your metrics to justify why the work that you're doing is important and why you're succeeding at that work, then you'll be a lot more likely to make it through the next wave. Other questions? Yeah. Yeah, so the question was, how do you measure those other things that aren't code metrics, so some of the conversational things? We actually have a lot of metrics defined within the Chaos project that aren't based on what we refer to as like trace data, so the stuff that you can just get out of APIs. But focused on things like, in particular, like diversity, equity, and inclusion. A lot of that is best measured by surveys. How do people feel about the things that are happening within the community and their place in it? So surveys are certainly a good way to do that. And you can also do, like, you can pull a lot of the trace data about conversations and do sentiment analysis and things like that. One of the things that we've done quite a bit within, like, Kubernetes community, for example, is try to push most things into GitHub, right? So even things like organizing the contributor summit, those are based on issues and markdown files. So people are contributing to those, and then you can see some of those other contributions for things that might not necessarily always happen in the repository. Similar thing for documentation. And same thing for like product management. A lot of that's done in the case of Kubernetes, GitHub project boards. So you can push a lot of stuff to some of these repositories for things that you might not naturally think of in that way.
I'm looking a lot right now at response frequencies. So whenever you look at issues or PRs, what are the conversations that are happening around them? The first response is kind of that initial look at it, seeing how quickly are people getting responses on either one, but then also how is the conversation going, like not even just looking at that first response, seeing if when the issue opener or PR opener, how long in that conversation thread are they waiting for another response? And then something that I want to start looking at, kind of that next stage of this, is seeing if there is a very large skewed behavior on responses for like different groups of people. So say if you look at like the top 10 contributors maybe, and how do they conversate with one another, then maybe how is the response to like a new contributor, or looking at different ways to break down the activity, because I think that there might be some trends that you'll be able to see, that some people get really fast responses and then some people don't get responses at all, and starting to take it a little bit more granular.
All right. Let's have a round of applause. Thank you, Callie and Don. FloorCon and HallCon are also still going on.
Okay. 1, 2, 1, 2.
Talk louder than that.
1, 2, 1, 2, 1, 2. Can everybody hear me? All right. Thank you.
There you go. We have 10 minutes. And then, how
Hello, good afternoon, everyone. Can you hear me? Is everything good? All right, awesome, thanks. Oh.
Oh, sorry.
Yeah, password man. All right, today we're going to be presenting about how to use open source tools to serve AI and machine learning models on private infrastructure. It is going to be a hands-on slash some parts were recorded, but the most interesting parts are live. So first of all, we want to present ourselves. Who are we? My name is Zion Ford. I work with Arcus Nexus, which is a software development company. If you want to take a look, we have a QR code at the end of the presentation. And
yeah, I'm Aaron Vega. I'm also with Arcus. Been working there for several years. I work mostly on backend services, and for the past few years, I've been specializing in cloud computing and infrastructure. So that's a lot of this is that's from where it's coming from.
So the problem that we saw, or why we are doing this, is that a few months ago I asked a question to my friend Aaron. I am not a very technical guy, so I asked him, how can we implement a private and secure infrastructure to manage a local LLM, and that it doesn't require any cloud services, and that it's all open source and using open source tools and technologies. So Aaron gave me the talk about how Kubernetes and how we can use it. So what I understood is that it is very complicated to actually do that. And setting up a private infrastructure in custom environments is not easy. So that's why we came up with this POC. So the proof of concept objective is to simplify the process of setting up a private infrastructure within a custom environment. For this demo, everything is running in the local machine. And the use case that we are going to be showing to you guys is an image recognition app that helps us find tacos in the YouTube videos. Why tacos? Because everyone likes tacos, right?
Yeah.
And
I want that. Just
go ahead.
So yeah, and we chose the image recognition use case because it's the simplest one. It's the hello world of the AI we've seen. So it helps us keep things tidy and easy to explain. So that's the reason. And also, no, you just go ahead.
All right, a little bit of high-level project overview. We're going to be using Ultralytics ULO V8 as the model for the image recognition. Label Studio for pre-processing and tagging our images. Jupyter Hub for the fine-tuning and, yeah, basically fine-tuning. And Docker and Kubernetes for portability and deployment management. So for those who don't know what Kubernetes is, go ahead, Aaron.
Yep, for sure. So yeah, Kubernetes is big lately, and if you don't know how it works, you can kind of assimilate it to a restaurant. Let's say we have a restaurant with multiple chefs that specialize in different kinds of cuisine, and each chef has to focus on just only the ingredients for that cuisine, for that style of cuisine, and preparing all the recipes that are according to that cuisine. And then if we have that scenario, we would need a chef manager that is looking up for the needs of all of the other chefs, making sure that they all have the appropriate ingredients for their cuisine, and also making sure ultimately that every dish is served according to the order that came in, right? So basically that's the job of Kubernetes in tech. We don't work with food, we work with the services. So basically Kubernetes is a manager for your services. It helps you with stuff. It helps you help check all of your services. So if you need to scale up or down, Kubernetes can take those decisions based on rules that you configure it to respond to. So yeah, we're gonna leverage Kubernetes to make this workflow work. The YOLO workflow, it's pretty simple. It's essentially 3 steps. Just pre-processing your data set. In this case, data set is a set of images, tacos. And then we will use Label Studio to tag those images in order to indicate to the model which object it needs to identify. So that's the first step. The second step, we're going to be using Jupyter Notebooks to fine-tune the YOLO V8 model. basically just running the training API of that Ultralytics provides, taking it from our data set. That way we can specialize our model to find tacos, right? And lastly, we're just gonna serve a small application that you can input a YouTube video, and it will process that video, find all the tacos in the video, and ultimately mark them up in the video. So the tools that we're using, we mentioned some of the high-level tools, but these are the behind-the-scenes tools. We're going to be leveraging Docker and for containerization and portability. All of our tools are going to be running inside containers, which is the way that Kubernetes needs their services in order to be deployed and used. And then for the infrastructure, managing the infrastructure, we're going to be using CDK 8, which is similar to CDK from AWS. I don't know if you're familiar with that, but that's basically just infrastructure as code. You can manage all of your infrastructure instead of using YMLs, CloudFormation manifests, and all that. You can use code. And CDK 8 works pretty much in a similar way, just specialized for Kubernetes manifest instead of AWS's. And lastly, we're going to be using Helm. That's just a package manager for Kubernetes. Basically, it allows you to bundle a bunch of tools into a single package that you later can install as a single unit in your cluster. So yeah, the setup that we have here, we have already skipped ahead some steps because just in the best interest of our time. It is all that you're going to be seeing here. It's already streamlined to a proper amount of time. But these processes take a lot of time because a lot of these images are on the gigs. So downloading them and installing them into your cluster, that's a slow process. So keep in mind that whenever you try this, it's going to take a lot more time than we're going to take here on this presentation. That's also the reason why we already set up some parts of the cluster, and we didn't do the whole thing live. So yeah, basically the first step for our project was setting up a cluster, and we needed a couple of tools for that. Since the point of this project was running the workflow in a private infrastructure, whether that be because you have privacy concerns or because you only want like a quick lab kind of setup or something smaller. That's some of the reasons why you would need to do this. So some of the components apart from CDK is the load balancer and the GPU operator. Those are core for running in your custom hardware. If you run this project in a cloud provider, you don't have to worry about those components because the cloud provider already takes care of them. It's already set up. You basically just spin up your cluster, and it already has access to the GPU if the cloud provider allows that. But we're going to be setting those up manually in our case. Now, for this demo, I've already went ahead and set up the GPU operator, which you can see it's a bunch of services. And the ones that we care are this lot over here at the bottom, especially the daemon set. That's a daemon set that's running inside the cluster that can talk to the hardware on the computer. So we can make use of the GPU in order to either train or serve the image recognition model. Similarly, I've also set up a load balancer, which I can. Yeah, it's this one. Load balancer, it's pretty simple. It helps you manage traffic incoming to your cluster, and it also tells or allows Kubernetes to know when it needs to scale down or up or allocate more resources to your services in case it's needed, right? And as I mentioned, if you're running in a cloud provider, you don't really need to do this. But if you want to make a point of running into your own hardware, you're gonna need to set it up. So basically that's it. And yeah, this is some of the parts that we already pre-recorded. This here that I'm playing, I'm just setting up the same environments, the same components that I just mentioned. I'm first creating a Kubernetes cluster, and then I'm going to install first the load balancer and then the GPU operator. And keep in mind, this video I'm going to actually skip ahead, even if it's short. It's about 2 minutes long, but this process takes about from 15 minutes to half an hour. So be mindful of that. Just because the GPU operator sometimes takes a while to spin up and recognize the hardware. But essentially, we are just going to apply some of the files that we already have in the project. Yeah, actually, I missed that part. I'm sorry. All of these that I'm going to show here is in a public GitHub repository that we're going to share at the end. So please keep an eye out for the link. And that repository has also a README, which is documenting all the process of setting this up from scratch. And also it includes a branch which is called Start From Here, which you can check out and start from scratch. Basically, you already going to have the load balancer and the GPU operator, but basically you can use that branch to bootstrap your own lab. So yeah, that basically is just running a bunch of commands. There are some workarounds as well, because we are using Kind. Kind is a development cluster for Kubernetes, and it has some issues with hardware. So we had to find a workaround for that. That's the Docker modification that we're doing here. Basically, we're just modifying or creating a symlink inside some of the containers in the cluster in order for them to be able to see the hardware. Sorry. Okay. Yeah, I actually. No, it's in the other tab. Okay. So the next step, once we have that's basically a bare bones Kubernetes cluster. What I just showed you, just setting up the cluster. Now we need to add our tools that we're gonna need for our workflow, and we do that using Helm charts, as I mentioned earlier. That's just a simple, not a simple. A package manager for Kubernetes that allows you to bundle up different tools into a single unit. So the two tools that we're going to be using are Label Studio and Jupyter Hub. I'm going to show you some code, and I'm going to try to, I didn't open the code, so. Oh, sorry, is that better? Yep. Like that? Okay. Okay. So yeah, the first thing that you're gonna notice if you follow or read me is that once you bootstrap your project, it already has an infrastructure as code folder and with some files. These are basically the files that CDK8 generates by default when you start a project. I just added a couple more files to handle the infrastructure that I was just talking about, the load balancer and the GPU operator. But CDK8, in order to allow us to create things, has the concept of charts, which are similar to Helm charts, but not quite the same thing. With CDK8's charts, you can define your own constructs that are going to be applied to your cluster afterwards. So basically, you code all of your infrastructure, you run the synthesize command, and that generates a bunch of YML files that you need to apply to your Kubernetes cluster. The advantage of this is that it's way easier to manage. It's way less code, and effectively you can also reduce the need for DevOps engineer because this allows developers to also step into the ops realm. So because it makes it more easy for them to manage, and they are familiar with code. So yeah, the thing this way works. The way CDK8 works is that we need to create one chart or multiple charts with the resources that we want to install into our cluster. What I'm defining here is an AI chart, which I have added 2 Helm charts, which are Label Studio and Jupyter Hub, and I want to install those into my cluster. All of these are documented on their respective home pages or the documentation pages. Jupyter Hub has a Helm chart, and it provides all the parameters that you can pass into the Helm command, which are the same that you can tweak here under each of these props for each of these Helm charts. So how does that look? Once we have ready, we have our sorry. There we go. Once we have our code ready, the only thing that we need to do is run the synthesize project, the synthesize command, I'm sorry. That's the thing that generates the YML files that Kubernetes needs to know what it needs to run. So basically, we have 2 files here, well, 3 files. 2 are from the previous infrastructure components that I was mentioning, and the last one is the one that I just compiled, which contains the Label Studio and Jupyter Hub. And once it creates, once it creates that, you saw that we also ran the kubectl apply command, which is the command that actually installs it into your Kubernetes cluster now. So if we want to see the state of that cluster, is going to be, oh, sorry. So yeah, basically this namespace contains all of the tools that I have installed into that chart, that particular chart that I was showing, and the outcome of that is that again, it spins up the services for both Jupyter Hub and Label Studio, but it takes a while to become completely green. So be mindful of that. But once that's done, and you can see that everything is running fine in your cluster, you can go ahead. Oh, actually no, I almost missed that. You can go ahead and check out under services. Both of these Helm charts create a service that exposes that particular application to traffic outside the cluster, and you can check those in here. So basically, for Label Studio, we have this external IP. Oh, where it is? Oh, here it is. So this external IP, which if I go into the browser, open a new tab and go into that. What's going on? You can see that we have our Label Studio instance running, right? And the first time that you come into Label Studio, it's going to ask you to create a profile. Since this is a local setup for the moment, it doesn't really matter what you input here, but you're going to need to create a new. Oh, no, it's already created then? Yeah, yeah. Come on. There we go. So yeah, once in Label Studio, what we want to do is create a new project, which is the construct that that Label Studio uses for us to upload our data set. So in this case, I'm just gonna do some name it tacos, since that's what we're gonna be doing. And here, once you have your project set up, you can import your data set. You upload your files. I already have it ready here. So you just, oh, sorry. How many images? Yeah, that's a small data set. That's not a, yeah, that's around 40 pictures. So yeah, but the real data set that we trained the model with, that's about 1,000 images. So yeah. So before you start tagging your images, it's gonna ask you to set up your project, which is obvious. So since we're doing YOLO, we want. I mean, we can choose from several of the templates there, but the one that I'm using is a simple square tags. So it already comes with a template. I'll just need to replace the provider labels. Create a new one. You can create as many as you want. For the demo, I'm just gonna create a single one, so I can we can see the proof of concept. So once you save that, did it save? Yeah, I think so. You can go back into your data set and start processing. We already see that we have here our tacos label down here, which is something that we want to use to tag images, but in this first image we don't have any tacos, so we're going to just skip it and go into the second one and just select this label here, and then we can just, you know, tag it like that, submit the frame, and you know, you get the idea. You have to do this a bunch of times until you no longer wish to work on what you're working on. So yeah, once you have done all of your oh, sorry, that's not it. All of your data set, you can export it, and the reason we chose Label Studio for this demo is because it allows us to export it in multiple formats, but especially the YOLO format, which is what we needed to make it work with YOLO V8. So you can export that and should download a zip with all of your images, all of your label data, and all of your tag data as well, the coordinates in which the images are tagged. Now, yeah, once we are done with that, we can jump into Jupyter Hub and fine-tune all our model. So let me show you also how we do that. However, this is also a very time-consuming process. So we already have it. We ran this like 2 hours ago. Basically, within your Jupyter notebook, it basically spins up an isolated pod inside your cluster your Kubernetes cluster. So you can install all of your dependencies in there. You can have multiple users having multiple you know, pods of their own, you know, or having multiple users access the same pod, so they can work in a collaborative manner, and all that kind of stuff. So yeah, we basically, what we did here was just install the Ultralytics dependency, and once that was installed, we just ran a small you know, we just ran 3 epochs just as a proof of concept, but we are running this in our Kubernetes cluster in our local environment. Sorry. Okay, that's for the training part of the workflow. But once we have all that done, we also may want to serve or model or make it available through some application or service or whatever, right? And the process to do that with Kubernetes is a little bit, it's both straightforward, but that doesn't mean that it's easy. All you need to do is create a Docker image and publish it into a registry, whether that be private or public, that's up to you. But Kubernetes needs those images in order to pull them and spin up new pods according to your indications, right? So our application is basically just a wrapper around. Let me just. It's basically just a wrapper around the YOLO V8 API. YOLO V8 provides a pretty neat API to either keep training your model or just you know predicting or inferring stuff from images, from video or images. And all I had to do was just wrap that around an application that received requests either to start a session or to start predicting. And all of that is contained in a Docker image that we can see the definition here. We're just building the application, which is fairly simple. You can look it up in the repository. But the important part here is that we need to use the Ultralytics image because that contains the tools to interface with the YOLO V8 API. You can do that with Python, which is easier. We kind of experimented here, and we did a Go application that kind of interfaces. It's kind of gimmicky, but it proves the point. So that's the reason why we wanted to do it that way. So yeah, basically you just need to use your Docker image. Once you have it, you can build it and publish it into your registry. And the way that we're gonna use it in our project is we're gonna add it into our same chart. You can add it into a different chart, but I'm gonna use the same one. And the first thing that we wanna do is set up all the registry secrets. These are Kubernetes secrets that we need to create in order to tell Kubernetes the credentials for the Docker registry that we're gonna be using. Otherwise, it's not gonna be able to download those images. So we did do that. We're using basically the same environment variables that Docker login persists in your system. So if you've done a Docker login in your machine, you can use this code as it is, and it should work for you as well. So we not only need those secrets, we also need to tell Kubernetes what to install. So the first component that we're gonna need to do or to specify is a deployment. And a Kubernetes deployment is basically, I don't think I showed, yeah. So a Kubernetes deployment is basically you setting up a bunch of specifications about your app, which image you want to run, the environment variables, and scaling rules, all that kind of stuff. You can set that up in your development. You have a pod spec here which you can modify the same way that you would in a YML file, but you can do it directly in the code here. So the deployment is the application itself. It contains the image that I was just showing you the Docker file for. But as I mentioned, we also need a service for the application to be available outside the cluster. So I'm also adding a new service, and what is important here is that we need to tell the service which port to redirect traffic to. So basically, I'm using port 8080 in my application. I need to set up my target port on my service to be the same as my application. Otherwise, it's not going to throw any errors, but you're going to be scratching your head, wondering why it doesn't work. So yeah, again, if in the README I go almost line for line explaining what each of these lines do, So if you have doubts, we have questions at the end, but you can also take a look into the repository. Right now, I'm just gonna compile it again. Let me see. And I'm going to apply again, but only the last file, which is the only one that I modify, the one from for our AI infrastructure. I didn't modify the other ones, but it doesn't really matter. As you can see, right now when I'm executing this, you can see that CDK8 is capable of identifying if any resources have changed against your cluster, and if it hasn't changed, it won't apply any other changes to that. It will just roll out the new changes to your chart. So yeah, what that did is that we should see a new pod in our cluster. Here it is, which it started like 20 seconds ago, which is the container for our demo application. 172. This should be. Oops. Which is our FAME tag finder. I'm just gonna pass in a YouTube video. I have the logs here, which has already started running, but you could also monitor that directly on your pod, looking at the logs. I don't have the lens metrics installed in my cluster, so I'm not able to see them. But you can do a kubectl as well in order to see that. So yeah, if we check at the logs, it hasn't detected anything yet. But what this is doing is, first it downloaded all the video from YouTube, and that gets passed into the Ultralytics API. Internally, Ultralytics they split up the video in frames and analyze each frame individually to find the object of interest, right? So yeah, we have some found, some hits here. And this is also something that takes a little bit of time. It can be improved a lot if you pre-process your video. So for instance, instead of passing directly the video from YouTube, we do some pre-processing and maybe modify it to say 20 frames per second. The prediction time it becomes lower. It's quicker. But for now, it's gonna take about 3 or 4 minutes, and yeah, you can see that it's running. Where is it? Yeah, it's running on the GPU directly, and it's running from our Kubernetes cluster. So yeah, basically that's it. Don't know if you want to add something else. Let's just give it some minutes to finish. We can check out the result.
Time while we are waiting, do you guys have any questions or something?
Okay, gotcha.
I'm more curious, where do you find all these, like, you strung together a lot of different pieces? It's just sort of trial and error, or there's certain resources you reached out to for?
How do we find all of these tools and?
Yeah, the tools, and you don't show the contents of some of these files you've applied for the cluster, but.
Yeah. There's a repository for help charts which you can look up. But I was already familiar with both Jupyter Hub and Label Studio, so I was aware that they had help charts provided for Kubernetes. So I would say it's a mix of experience and research, because once we settle on the proof of concept that we wanted to make, we also had to do some research to see if which model was the one that fit best for project, and if the tools that we had already selected were the right ones. The Kubernetes part is that's experience. I've been working with infrastructure for over 5 years now, and mostly doing Kubernetes. So actually, yeah, the thing that we didn't mention is Cyan came to me because he's working with a customer that does AI stuff. There's actually like a personal assistant. They have a booth around, but he wanted to simplify. They have some concerns. They need to run into custom hardware or more a local setup, and we started looking from there. You know how we can accommodate that and make a proof of concept. Researching the tools, researching the methodology. As I mentioned, it wasn't it was straightforward. It wasn't easy because there were so many workarounds that we needed to weed out. But yeah, it was. We did a bunch of research at the beginning. We had a lot of experience, but ultimately we had to also, trial and error a bunch of stuff. So I would say it's a combination of all of those.
Is the model selection mostly just you have some pictures and you run through this process and then see if it spits out what you expect, or?
Oh yeah, you mean the fine-tuning process, right? So yeah, basically, once you can run this is an iterative process. So you run your training several times, and the output from YOLO is these checkpoints, these weight checkpoints, which tells it gives you the last iteration that you ran, and also the one that had the best results. So you can pick up the one with the best results. And how do you know which one had the best results, right? So how do you know when to throw out some results from your training or not? You have to monitor I believe this is the average precision, median average precision. I think that's the name of this stat here. This should increase over time until you reach your desired accuracy. So for this demo, we just settled for around 75 to 80% accuracy. So we train our model until this value here came close to that value. I don't know if that answers your question. Yeah. Okay. On the back. Yeah. Well, no, that's kind of like a quirky choice that we made because we just wanted to experiment. And actually, the only Python that we use is this script here, which is just telling YOLO VA to, hey, we need to train again. So that's it. But our application, our Go application, uses the CLI actually, the YOLO VA CLI. YOLO VA also has a CLI which you can use on your local system if you don't want to set up this kind of stuff. So let me see if this is ready. Yeah. So here's the result, right? So it's not perfect. As I mentioned, we are aiming around a 75 to 80% accuracy. It gets confused sometimes, but overall it works. And by the way, Habaneros is not a sponsor in any way, but shout out to them. I hope they're doing great. So do we have more questions? Yeah, over here. Yeah.
I don't know how long.
Yeah.
And your API will just not work.
Yeah. Basically, that's I believe, I'm not 100% sure, but that's a partnership kind of thing. Ultralytics provides that part of they handle it internally, so we just pass the link and they download the video on their own. So yep. That's like an API, right?
Sorry.
Yeah. Oh, okay.
So you could use that, or there's an excellent plugin for Firefox that skips my mind at the moment where you can download the video.
So the question was, how do you get YouTube to let you have videos that's not annoying full of ads manually and the endpoint changes?
Yeah, and also I think they limit the rate of.
And the answer was that the yellow thing that you're using seems to have a
Yeah, they
deal or something?
They seem to use some sort of API over here. I think it's this one here. Yeah.
Do we have other questions? Is it question time?
Yeah.
We're at the question
Yeah,
period?
yeah.
We saw the tacos.
Thank you for your talk. The CDK8s, that's not a substitute for kubectl at the command line, because I saw you using it for setting it up. So you still use kubectl to communicate, and it's just adjusting. You still use kubectl in YAML files. I thought you said before it was a substitute for those, but I guess you still use them, but it's controlling the
It
Helm
helps
charts
you
and it's
manage,
controlling the back. So okay.
Yeah,
Do I have that right?
Yeah, exactly. So the question was that if the kubectl is still relevant while using CDK8s. But yeah, it is, because the output of CDK8s is still YML files that you need to apply to your cluster. But if you use CDK8s alongside CDK, which the AWS CDK, those two are interoperable. You can invoke CDK8 shards from CDK, and they will execute. So you don't need kubectl on that scenario. But for the rest of the world, we just have to deal with it. We had some more questions.
Yeah, I was just curious what GPU you have in there.
GPU, that's GTX 3070. Oh yeah, actually yeah. Yeah. Yeah, we were looking into that, but we couldn't get one in time. So yeah. Do we have?
You said you had a like a walkthrough tutorial or something?
Yeah,
like full instructions?
Actually, I haven't shown you the last. Sorry for this. So yeah, you can check out the repository over there and give us a follow on Arcus Nexus.
There we go. Now we got a lot of phones up taking pictures. Any other questions?
Over here. Yeah, for sure. It's more. Yeah, it's missing those. Yep.
So my question is, have you actually considered using operators to kind of automate some of the things that you just did today? You could just like run them in the cluster and just feed the models into them and get the results.
Run
faster.
operators?
Kubernetes operators.
Oh no, actually I haven't looked into that, but yeah, that's
makes
a good,
it faster.
That's a good point.
Yeah,
Yeah.
you can natively run them. Yeah.
Yeah. Over here in the front.
I'm taking the long way around, getting my steps in.
So it looks like GPU operator is doing a bunch of the heavy lifting for the NVIDIA setup, right?
Yep.
So you're on a single node box because you're just running on your workstation.
Yeah.
Does it auto-detect which nodes have NVIDIA, and do you do something in your deployment to say which nodes to schedule to?
Yep, that's a good point. I can show you right over here. We have, we have some files for cluster definition. This is specific for kind, but you would have to do something similar for either bare bones Kubernetes or any other cluster provider. But yeah, we are telling it here, creating those files in the mounting rather into the containers. So those are the ones that allow the nodes to talk to the GPU.
All right, big round of applause for Aaron and San.
Thank you.
I'm sure they'll be happy to talk to you for a few minutes at the front or in the hall or
Yep. Thank you very much, everyone.
on the way to dinner.
Test, test. No.
Get it in good and close.
Oh no. Try it again. No. So let me try this one here. Test, test. Can you hear me? Can you hear me? Uh-huh. No. Up. Is the sound? Yeah. Good. Perfect.
You're a louder speaker than some of the last ones, but you're a bit
Yeah.
quiet.
Yeah.
Any SCaLE first-timers in here? 1, 2, 4, some more that I couldn't count fast enough. What about SoCal locals? Who's traveled the farthest to be here? We got a Texas. What? France, Germany. I think that beats Texas. Sorry, Texas. I have a cousin who's French. My grandparents met during World War II, and my grandmother came back from France. I sent a letter to a 20-year-old address in France and got an answer back and went and visited my family in Villers-Saint-Paul. Anybody coming to game night? 1? Two-minute warning. Okay, I won't make it. Fast, the doors are closing. Not really. Okay, it's 5 o'clock on Saturday in Pasadena. This is Optimal Approaches for Real-Time Machine Learning. Warm welcome, please, for Hishem Kanish.
Thank you. Oh.
Switch you microphones, I think.
Can you try to put it back in the pocket?
We've reached end of life.
That's the end of life. Okay, that's the... Oh, can you hear me at the back? Perfect. Okay. Yeah, so thank you for joining this talk Saturday, 5 p.m. It's the first time in my life. I have been around for a long time, doing a lot of conferences. First time I'm giving a talk at 5 p.m., especially here, I guess, in California. Anyway, so my name is Hisham. I'm from France, as I said, and I want to talk about, so the original text, the original title, sorry, was not all this shiny technical words. It was how to treat coronavirus fatigue and burnout by cycling to the office. And you will see, you will see how things will lead us to that. So, I mean, the official thing is how to use Spark on Kubernetes, Apache Spark, which is another foundation. We have a lot of things happening here around Linux and Linux Foundation, but the other foundation that manages a lot of software, Apache one. So how to run Spark on Kubernetes specifically for machine learning and when you want to run real-time machine learning. Okay, so a few words about me. So I'm an open source project architect with InstaCluster. We have a booth. Please come visit us if you want to learn more about InstaCluster. We are part of NetApp. So I was, previous jobs in my life, previous lives. And I have had a lot of kind of data engineering / a lot of machine learning, but from the platform and tooling side of things. I'm not a data science expert. There are a few data science experts in the room. If you but don't challenge me about models and stuff like this. I do understand, but this is not my main topic, is how to put all this stuff into production and build more tooling and platforms around this. Okay, just a quick disclaimer here. It's important that to kind of reiterate there is no contribution to any open source. This is like a project that we have been doing internally and with a broader community. So it's not, there is no, hopefully we will get there maybe to contribute to some of the open source project we're using. Yeah, my vision of things is necessarily biased. I'm talking about these two technologies, by the way, which as I work for a company, we offer a managed services for Spark and on Kubernetes. So I'll be biased and challenge me, please, if you think there was something that was too biased. And the main thing is this work is based on principle of open source, whatever open source is, open data. We use a lot of open data, and the culture of knowledge sharing, whether it's with researchers or engineers or volunteers of any kind. And yeah, human learning is a lifelong work in progress. It's my slogan. It's everything we do can evolve and we keep learning. The agenda for today is pretty packed, so I'm trying to kind of, go as fast as possible to cover everything. And then again, I'll be around if you want to ask any question. There will be no demos. The last one was a fiasco, so I'll put everything out there. If you want to, have a look at the stuff we're doing, we start just putting notebooks and we're putting things together. Yeah, I will not mention the team, but there are people from Australia, a lot of people in France, and people guys and girls in the US working on this. For now, we wait to get all things together. So I didn't mention the team, but it takes a village to build something we're trying to build here. Okay, so what is the story here? After COVID, burnout, something, I decided to do cycling and only cycling to the office, okay? So it took me like an hour to cross Paris east-west to get to a NetApp office. And I start looking and discovering all this stuff, and OpenStreetMap is really amazing. There is a vibrant community of cycling, cyclists, behind a lot of things happening there. But, start cycling was new for me. I started struggling a bit to get to work on like having the same kind of ETA, having the same time, a lot of struggle to get there. So I wanted to, first thing first, like avoid traffic with a couple of guys. Like we were cycling to the office, but all this stuff are static, just provide you, go from point A and B and provide you for different kind of, maybe 2, 3, not recommendation, but routes or paths. So like, how can I get there maybe by avoiding traffic, because traffic affects cyclists and obviously pedestrian also. So I went to, I don't want to mention or name it, I went to this app that we all use, and I say, maybe this is pretty amazing, like maybe if I use it, I can avoid traffic, and I end up in a parking lot. Yeah, there were a lot of accidents and closed roads. So yeah, so the guess was maybe, yeah, definitely it's not the right app. We can use other apps and stuff like this. And I said maybe Paris is not the capital. I mean, it's not a city known for cycling. So trivia question here, what is the capital of cycling in Europe? Yeah, Amsterdam, great. So I said maybe I can check what's happening there in Amsterdam. But the result was the same. And these guys, I mean, girls, they have exactly the same question. What's wrong with the algorithm of Beep? What's wrong with it? Why it cannot show, things that are smarter, like, than this? And then if you look here, and you all understand French. Yes, you guessed already? No? I'll help you in this. So all the paths or all where the recommendation are not based on real time or real condition. They don't take into account anything. So, I mean, I'm not doing any bashing or anything. This app here, I mean, this is the best that you can have actually so far if you want to go in cities from one point to another. So this has really like great features and you get a lot of information, but I was expecting as a tech guy that this kind of things like, are easily, like, easily can find a solution for this. Okay, we pushed the things a little bit, more than this, coming from COVID. We have all this conscience around, being healthy, being more like, avoid get diseases and stuff like this. So while you're cycling, while doing effort, it's really bad. Like, you can think about all higher concentration of pollution that arise near, like, road and networks. So I was thinking, how can I get there? How can we get there? And maybe try to get the least air pollution exposure routes, So have the least traffic, let's be ambitious, and maybe it's an utopia, and have everything in one place that give us like different criteria or based on different criteria and give us the best route from one point to another. So unfortunately, same problem. There was nothing out there. There was, some kind of, work mainly in academia that started mainly in Europe. Then it was taken. There was a lot of work happening in Asia. I think it's a really big issue in India and in China, places like this. About air pollution, but you see that there was at least people start thinking and sharing, and like a lot of research articles around how we can adjust, how we can predict, how we can use, at least machine learning at that point, like graph neural network approaches to predict this kind of things. And I mean, you can see where I'm going here. You can do this stuff only if you have real-time capabilities. Everything that happen on, like, at like where you are traveling, where you are cycling, where you are walking to work, everything that's going to happen is going to affect your route in terms of pollution and exposure to pollutant. So yeah, we also kind of try to check in different areas where there was something equivalent, but we didn't get, we didn't find anything relevant to reuse, at least as a open source. Okay, so just one definition here, at least in our context, when we say real time, so real time means that it's near real time. Okay, we can discuss it here. We kind of, care more about getting the right information rather than the speed of getting it. So, seconds are tolerable. Like, we are not going sub-seconds to generate paths. So this is like the kind of target. And real-time machine learning, in this case, is just the application of machine learning, the usual machine learning models and approaches to make decision in real time and based on, changing environment and based on information that you gather. There is an accident somewhere. There is, I don't know, a peak in pollution because of traffic. There is an event. There is a game tonight in LA, by the way. There will be probably a lot of effect. And we want to capture this stuff. We want to get all this in one place to, get the most relevant prediction. Okay. So from thinking, from whiteboarding to building something. So here is the kind of, open source stack. Again, you can challenge these choices. There's probably 10 others that you can choose, and it will be legit. We started with these building blocks, they were common, there were a lot of help community, and we had a lot of skill set around, at least in the company. So we have contributors to this open source where we can tweak and twist the knobs if we want to kind of tackle challenging stuff. So at a building block, and this is what I'm talking about, is, Kubernetes, everything runs on Kubernetes. There are some exceptions, but in this case, everything runs on Kubernetes. And the key thing that, at least Spark and Spark structured streaming is the building block of our processing and our training and, the whole kind of brain of the platform. You could see things that honestly I have learned on the fly, like feature store, at least, and worked in past on aspects like this, but an online feature store was pretty amazing. Things like that act between a bridge between data and machine learning. There were a lot of key aspects that I learned, but let's focus here on the kind of the main thing, which is the infrastructure side. Okay, so what is the biggest challenges, at least that we faced, or like a lot of data in a more broad or general meaning, data teams are facing when they try to transition, try to tackle real-time machine learning. So I had a lot of inspiration and interesting discussion with Chip. She has been doing an amazing job in this field. She has an amazing website that you can read. She did a lot of interviews. She went to a lot of tech companies in the US and China, and she collected a lot of information around challenges when we deal with real-time machine learning. She has, of course, I will do some publicity for her. She has an amazing book if you want to learn more about designing machine learning system, and there is a whole chapter about real-time machine learning. There's another mention also to Noah for practical ML ops, and it is, I think, another book coming. So we kind of had two different challenges. The one from the machine learning, or like say the data science side of things, it's about modeling. It's about how do you extract features, about what is the cutting edge model using, like attentional neural graph networks and stuff like this to train models using geospatial time series, and name it, like a lot of stuff. These are like, I can say, the blue stuff. And the other side is the infrastructure or the tooling stuff. And I cannot agree more with Chip and other experts on the field. The problem, the challenges are from the infrastructure side. I'm not minimizing, of course, the work that is happening from this side. But if you look at it, guys, the problem is from this side here. We don't have any blueprint. We don't have any kind of people sharing knowledge on how to stitch things together, how to build things together. It's still kind of new to have something common that is adopted and kind of stress tested, at least in the community. So yeah, these are the challenges, and among them, since we don't have enough time, we kind of focused on the scalability. This was a key. Long-running, never-ending jobs, collecting, sensing information forever. You have peaks. When we have scalability, sometimes, of course, we have to think about costs, so we have to scale down or reduce the workers, or you reduce all the infrastructure as soon as possible. Latency, of course, is key. Here, when I mention latency in this talk, I mean mainly latency about the processing. I will not mention latency about serving, which is another challenging area. Monitoring again is key. I'll try to explain why. And the distributed training and inference, which I just said that I'm gonna kind of avoid for this talk. That we try to cover here. Okay, so in real time, what is the most critical aspect is to have the freshness of the features. Well, the features is just data. As we said, the serving latency, the possibility to have the accessibility of data and these pipelines always running in a robust, in a reliable way. This is a kind of key definition or a building block we want to keep in mind where building this work. And yeah, so Spark and Kubernetes, so the streaming aspect of it, we could manage stream processing, as I said, training, scalability, and resource efficiency, which was key, especially when we start dealing with deep learning stuff and GPUs. And we start burning a lot of money, and companies say, different companies we work for say, like, you have to be careful with your GPU bill at the end of the month. Okay. It's customary to ask questions just to check that you are still alive, but it seems like you're doing okay. But it's really legit. I want to ask you, who is using Spark on Kubernetes? Okay, no one. So that's a good transition in that case. I will kind of go back to the genesis, not genesis of Spark, but why we moved from Spark from the Hadoop ecosystem, or at least Yarn, to Kubernetes. So Apache Spark is the #1 analytics engine for big data and AI. This is as objective as I can say. The reasons are it has 2 green stars so far, or still. It's versatile. It can do ETL, ELT, real-time, machine learning, BI. That's really key. We don't want to use one tool to do just real-time. I mean, you can see where I'm going with this. It's easy. This is subjective, but you bring someone from Java background, Python, SQL, they can interact with Spark. The distributed aspect of all this big data is kind of hidden. under the hood. We have a lot of framework that you don't have to think about how your workloads are distributed, how your Python code even is distributed. You just write code and it manages the distribute aspect for you. And it's fast, or at least it was fast. This is what it has like start to be a gray area, and we can discuss it, but it was fast until like recent framework to do like massively parallelizable read and write and processing, okay? So this is Spark. It was born in that ecosystem, that era of Hadoop. You know, Hadoop is still around. We cannot say still like, you know, the king is dead, long live the king. It's still, Hadoop is still around, and it's gonna stick around. So Kubernetes is the new framework, but I think, you know, as I was saying, Hadoop will be still around. So in Spark can do all this processing, but it needs a cluster, what we call a cluster manager. So cluster manager does all the orchestration of the jobs and all, like just in a nutshell, it knows where to put a processing unit in which worker. Worker is just a VM or like a physical machine, just to kind of simplify things here. So it went through different resource managers, all from the Hadoop ecosystem era. There was this standalone built-in like functionality, but really limited. But we had Mesos, that is gone already, and Yarn, which is still the most widely used. And Kubernetes is the most popular or the last cool kid in the block. So we're really happy that this was a reality for Spark users. It took an amazing team, a community of people to do this. And I like to say that from the Apache Foundation side and from the Linux Foundation and the CNCF to work together to make this like as a reality. So like this is the history of the Spark on Kubernetes, sorry. So it's kind of recent. It went GA in 2021, okay? So there are still a lot of work to do. And as for the last version, we have like, you know, we still have a lot of major enhancement happening in Spark on Kubernetes. So just to give you a sense on what was the limitation of Spark on Yarn, the key thing is, the key problems, like you had this global Spark version. You can see like now retrospectively, we know how it's doing. It's definitely good, better on Kubernetes, but this problem with isolation, a limited, put a star there, but it was really limited Docker image support and a lot of resource overhead. And this is just like to give you an idea how Yarn manages the cluster for Spark. As for Kubernetes, of course, you know, you have this native Dockerization. You have like simpler dependency management. This is really great when we train machine learning model. You have reliable execution. We can do isolation, you know, like, you know, when you have containers. And of course, you get the benefit. It's a standard agnostic cloud infrastructure. Yeah, that's a really important point, not to kind of miss it. And one of the key things I've noticed, there is this rich ecosystem for Kubernetes that Spark users like us, you know, can get, you know, advantage of. That's a really cool thing. There is two ways to run Spark on Kubernetes. There is the old-fashioned Spark submit, okay, if you're familiar with this. And the other one is we are lucky, and there is a Spark on Kubernetes operator. Really proud that we, as you know, the company I belong to, we contribute and maintain this Spark on Kubernetes operator. It was open source by Google, but actually you can use it on any platform. It's really open source, and it's config like, you know, YAML style with sugar on top, I say, with config maps, volume, affinities, things, And we have a concept that we created locally in our words. It's called VNGs, Virtual Network, Node Group, sorry. So yeah, this is the Spark operator. And as I said, like, you know, it's also a really kind of active project. We are having a lot of support. And I kind of, you know, insist on this. It's really important that if you are planning your journey or for at some point, you know, you want to test Spark on Kubernetes, please don't use Spark Summit. You will hate it. And because, you know, it's bad. Use the Spark on operator and you will adopt it. And yeah, I am asking you, like, if you're starting this journey, if you're considering moving to Spark, and Spark, especially Spark on Kubernetes. If you're running Kubernetes already, it's easy just to deploy, you know, like a Spark cluster and try to start testing it. And this is not just an engineering, you know, to kind of migration to the next tool. It's really kind of has some distinct advantages I was showing you. And if you look at it, this is this was from AWS. Just the this small kind of cut or cost reduction for some of our customers, it's represent millions of dollars per year. So it's really huge. I mean, in terms of cost, in terms of management, in terms of a workforce, like an army of engineers you need to maintain something like Spark Summit or Spark on Kubernetes. So that's really kind of, it's justified, and the whole industry is going to that, this way. Okay, just some challenges of running Spark on Kubernetes and offered solutions. So as we said, we're trying to talk about monitoring, scalability, latency, and model training. This is the iceberg. Don't be scared, there's no Titanic in the story here. We are kind of definitely in a situation where there is a lot of logs. Logs everywhere. So I would recommend that you start thinking about this. If, again, you embrace the journey, start thinking about your monitoring, your login monitoring before anything else. Like, you know, even if you are doing dev, even if you are doing experimentation, try to have these building blocks in place, because as I was telling you, there are events from Spark, we call the driver, the executor. As you said, it's a cluster, maybe sometimes thousands of nodes in some of cases. There are Kubernetes logs, and it's really hard to reconcile all this together in one place. So again, an amazing ecosystem, and FluentBit is something that really helped us a lot, and Prometheus, which has a built-in, Spark has a built-in Prometheus in it. So this is something that I recommend. Again, there is a consensus in the community about what to use, but this is a building block, and this kind of, you know, iceberg become more controllable, more easy to kind of, you know, monitor and log. One of the key things here also is that when you do this monitoring, what we discovered is that we learned a lot of things that we were not expecting from monitoring. We learned things about, like, you know, executors over provisioning. We learned also about like partitions issue, which is like a common disease with Spark, and a lot of things that we learned through our monitoring system. So I really recommend that you kind of shift the paradigm. It's not just like, you know, to kind of firefight if things happen, but it's also to help you to be more proactive, because the complexity of such system, you need to have, like, you know, this proactivity if you have machine learning, real-time machine learning jobs running in Spark on Kubernetes. Scalability. So scalability, there are 3 key factors here to consider. cluster sizing, infra choices, and specs. When I say like spec, the kind of VMs or the kind of, if we are on AWS, the type of EC2 instance you want to choose. Dynamic allocation, I'll try to say a few words about this, and the shuffle data. So shuffle is just like, if in a nutshell here, if you are not familiar with Spark, shuffle is all the data. Since we distribute the data on each workers, shuffle is the data that we kind of transfer from one worker to another through the network. So this is something really important and kind of symptomatic in Spark. So there's these three kind of building blocks, that we need to consider here. So for sizing, it's important to just, there is no automatic way to do this. It's just common sense, and don't forget what, like best practices from software engineering. It's just a continuous and repeated exercise. You need to know at some point your data sources. So the clusters that you need to put in place and the type of instances need to be like, enhance your parallelism in relation of the sources. So parallelism means that you want to treat in parallel different events or different data coming, and your resources, your compute resource needs to be kind of geared and configured to respond to this kind of data you're having in streaming. So streaming is CPU bounded. CPU bounded in this case means that we spend a lot of time doing CPU. It's not like an input-output. We don't do a lot of reading and writing, but you have to be careful in this case because we, in our modeling, we do a lot of stateful, we do a lot of aggregation and stuff like this. So we have to choose resources that are like CPU optimized, but we have to think about memory because we keep a lot of state, especially in streaming, state event in memory. Deep learning, so as I was telling you, we used a lot of GPU, at least in the training phase. You have to be careful also not to burn a lot of GPU on this. We have a mix of CPU and GPU on our Kubernetes. We have, as I was telling you, what we call virtual node groups. We create affinity intent, and it helps us to kind of make sure that only the relevant workloads go to GPUs. Yeah, and we actually, just to finish this, it's a mix of CPU and GPU, and we make sure that we spend a lot of time on CPU rather than GPUs when we're doing with this kind of things. Okay, dynamic allocation, maybe since we are not all kind of, this is like a really advanced topic into Spark, but what it does, just in a nutshell, so it's kind of do an auto-scaling, like the same thing we have an auto-scaler on Kubernetes, but it's tend to do it in a smart way. So for everything but, it works perfectly, and it's really great feature, but when it comes to structured streaming, it becomes a little bit tricky, and it works really poorly for certain application. So, and I mean, you're familiar with these Jira tickets, and I have been watching this ticket, I think, for the last 4 years. It has been open. I mean, we still have a vibrant and a lot of committers, but just to show you the complexity, there is no agreement on this. How do we dynamically allocate resources for streaming, structured streaming jobs? So this is independent from Kubernetes. It's just a Spark problem. So when you run Spark on Kubernetes, it adds more complexity, and this feature may cause a lot of issues. So you have to be really careful with this if you want to use dynamic allocation, and don't trust. There's no kind of autopilot in this. I would say another thing is the shuffle problem, which is like somehow a consequence of the problem we're having with the dynamic allocation, but not only. So this external shuffle topic has been around for a long time, and we have been waiting. You see that some of these future work external shuffle service, hopefully it's gonna come soon. So there are different open source frameworks that help you to have this external shuffle service that store your shuffle data. One from, obviously, multiple from AWS. So you have 1, 2, 3 from AWS, one from Intel, and another from IBM. And we have been testing, not to be honest, transparent, not the last S3 CSI driver and the high performance storage. But the other one we have been playing and trying to reach out to the creators and the maintainers of the project. And it's like a choice, a rational choice, or a educated and says choice here in this case. And we're using the IBM Spark S3 Shuffle, but it started from 3.2 Spark, like most recent Spark version, and it helps us to kind of tackle this problem of the external shuffle, whether for batch or for streaming, it works perfectly. Latency. Again, this is just a small remark, and I would say it's like for the young generation, or maybe just people who are starting in tech or want to learn a few things. We used to learn, I mean, for those who lost hair like me, we used to learn latency numbers every programmer should know. And it's kind of fascinating that a lot of young, I mean, kind of, they don't know anything about stuff like this. So it's the basics or the fundamentals are really important. So we may talk about cutting edge machine learning and Spark and Kubernetes. But at the end of the day, it comes to knowing your basics. And in this case, so latency, we spent a lot of time doing whiteboarding session, and as I said, it's just the processing from a Kafka topic, Spark structured streaming to a Kafka topic. This is our kind of highway. This is our key pattern, and yeah, kind of key things I would recommend to look at, to watch out for, is the Spark configuration. So whatever you learned before from your Spark configuration, kind of you need to tweak this and make sure you kind of master what you're doing. Sub-second latency expectation are a challenge, and I can guarantee you for this project with the amazing people I have been working with, it's really hard to get. Even though a lot of people out there say they can reach sub-second latency, this is something really hard to get. And yeah, it's always like a trade-off between using stateful. Stateful, again, is like when I'm doing streaming and I want to keep a state. Like I'm doing the aggregation, I want to count the number of red cars I get. Like every time I have a sensor on a highway, just to give you a sense of what we're doing. And I'm counting the number of red cars that are going through the highway. So I need to keep the state. I do a lot of aggregation. I need to keep a state. Stateless is when I don't care really, what's happening. It's just like which car has the car that I'm seeing. It's just like red or black or whatever. So it has to do with design and the problem you want to tackle, you want to solve. Now, this is a really important thing to take in consideration. And things that we learned is use as much as simple computation, just like when you're doing your data transformation or enrichment. If you want to do complex joins and stuff like this, you won't succeed in getting anything latency, reasonable latency. So be aware of this. This is a lot of common sense, but it's important to kind of remind that these still works pretty good when you're dealing with these complex systems. Yeah, so this pattern always use a message bus Kafka. I would say before and after. In our case, it's Kafka, Spark, Kafka, and we have another pattern which is Kafka, Spark, and we have Cassandra or Redis. You always use this. Rather than we've seen some configuration where supposedly by removing all these layers or all these middlemen, we can increase improve the latency and reduce the latency, but it doesn't work this way. By removing something like Kafka, you lose a lot of functionalities in your platform. Yeah, I mean, RocksDB is just a new feature on Spark, and it helps to store all the state, especially when we said, like, mentioned the stateful streaming pipelines, and it helps to keep all the states, and we don't end up in this GVM out of memory and other issues. ML training, this is really amazing. I mean, a lot of ML frameworks, especially if you are coming from, like, I would say the mono worker, you just running Python on a mono machine or a single machine. It's kind of disturbing because a lot of this framework were designed for single node environment. Spark is another, as I was describing, it's a cluster. When you have like multiple machine, you have to distribute and parallelize your workload. So this is something you need to think about before you choose a framework. And Spark MLlib, which is like a native machine learning library in Spark, is lagging behind. Hopefully I'm not in the Apache Spark conference. I will probably get people screaming at me. But yeah, I'm saying that we should probably contribute to this, but it's kind of, not getting obsolete, because I intentionally put this, we have things like Torch distributor, which was included recently, that is still live out there, but all the modern frameworks are not there. So what we did is definitely use, like the major kind of framework, TensorFlow, Keras, and PyTorch. And yeah, things like Horovod, TensorFlow extended. And there is this, I mean, it's open source, but yeah, at some extent, there's no one from NVIDIA in the room? No? Okay, I'm safe. So it's open source, and it's pretty amazing tool. It's kind of unified for ETL and machine learning, which is great. So you can really kind of, using GPUs, which is, I was asking my friend recently, like, I don't understand how GPUs can accelerate things from ETL and ELT, but it works. It works pretty well. So you have, like, with the Spark Rapids from NVIDIA, we have like a really nice framework that we used intensively. It's just like, it's really hard to run outside NVIDIA. So we said, like, we are doing a lot of open source, and we are kind of, having this philosophy of sharing, and you can run it on your any commodity hardware. So this is a bit, complicated, I'd say, at this point. But yeah, we have using these frameworks, and they're pretty easy, and we kind of publish a lot of Docker image out there where we package everything together. A lot of companies are using not our product, but at least our Docker images to do a lot of stuff with, especially the NVIDIA Spark Accelerator Rapids. Okay, there is another thing. I mean, Spark on Kubernetes is great, but for batch, because anyway, even when you do in machine learning, real-time machine learning, at some point you will have to do some batch. And the default scheduler, the default Kubernetes schedulers kind of, lags a lot of what we call like specific scheduling strategies. And so, yeah, it's kind of end up doing a lot of starvation for jobs and deteriorate the performance. So the solution for this, there are two major projects, Volcano and Apache Unicorn. Volcano is in the SCNCF, and it's growing, and there is a vibrant community that is contributing to this. And it's really good. It's as a custom scheduler. We can do like job priority preemption. We can do zone awareness, because we can discuss this also. Like latency matters when you want to co-locate your workloads in the same kind of data center. So we can do a lot of things around, especially with Volcano, things like, as I said, task topology and job priority and gang scheduling. Okay, for the deployment, this is really something that it's kind of, there is no, we have no kind of guarantees yet. We didn't benchmark anything, but like just as this mlops.org, deploy your model. Yes, package your model as a Docker image with all its dependencies and push it. We are using, kubeflow and kserve to do this, but this is not easy. You end up with huge Docker images. So we are still thinking about model optimization and model compression. They're really important. And we are experimenting with ONNX runtime, which is an open source from Microsoft. I don't think it belongs to any foundation, but it's still maintained by Microsoft just to manage all the dependencies. And yeah, so with all this, we achieved a platform that I was showing, and especially that criteria around latency, around scalability, and having a monitor platform in order to build or tackle this real-time machine learning. So I will try to conclude quickly. So yeah, try to convince you again, if you are starting your journey, if you want to experiment at some point, Spark on Kubernetes is the thing to go to. Native integration. Yeah, you have all the best practices and best things that apply to Kubernetes, apply to Spark for free. We kind of could achieve scalability, latency, and other things like fault tolerance, model training, and serving with some caveat with the serving, and integration with the ecosystem. Okay, key takeaways. As I said, use the operator. If there are any contributors, please contribute. Monitoring is really important. Use the best practices from Spark, compatible with Kubernetes, the rich ecosystem, and contribute to the OSS. There was a talk on Thursday saying that open source is not only code, and open source, I can confirm, is not only code. So share everything you have there, share your experiences, write a blog on Medium and say, like, yeah, I struggle to do what this guy was telling for an hour. It doesn't make any sense. And share your code ideas on GitHub, share your challenges. This will help the community, and this will help, grow and try to solve real life problems. Because remember, my problem was to be healthy, was to stop using my car, maybe solve the planet if I can, save the planet, sorry. And technology can today, recommend the best movie or the best food, or in real time, the next movie I have to watch, but not as I said, solving a real life problem that maybe will affect all of us. And that's all for me. Keep cycling when you can. That's all for me.
All right, are we ready for questions?
Hi, great talk. On one of your slides, you had Kafka going to Spark, going to Kafka again with RocksDB in the middle. Why not just use Ktables or KSQL? Why add Spark if you're already in a Kafka infrastructure?
So because, we have this common pattern, and I should have justified this. So the reason is that we kind of write from topics that open data come in real time. So we need a topic in Kafka. And I guess why do we have to put Spark streaming in the middle? Because we do a lot of complex transformation that we need something like Spark that is distributed, that is robust, and we do a lot of parallel joins from different streams. And then we write back to another topic, and this topic is used for feature extraction. Did I answer your question?
That's what KSQL is for.
Again, this is something we should probably consider and remove stuff like this, but we definitely need it at some point. something that can scale and be highly, I would say, distributed to do this kind of things. I'll definitely have a look at KSQL. Thank you.
More questions? One up here.
Regarding monitoring the Spark structure streaming job, like there are two ways you can monitor, like writing a listener, like async listener or a sync listener. So, but even if you write a asynchronous listener, you still get the logs, like only the logs. But one of the struggles we are getting, like how do you get inside of the log? You go to Prometheus or Grafana. Have you tried that kind of stuff? Or
So yeah, that's a good point. Actually, we use Prometheus directly on the workers to collect the logs, and we tend to kind of reduce all the noise. We target. This is a learning process. We target few metrics that matters for us. Like we make sure that metrics A, B are there. And we kind of, on the fly, we do this process and we reduce, we kind of parse and reduce all the logs we want to collect from the workers. And we do this with Prometheus. Yes, yeah. We use these tools, but we kind of, there is some intelligence, there is some work to make sure we are not having everything and we need to parse it and then, kind of process it. We just collect from the source only the metrics that we're looking for. This will kind of add some latency because this is a process, this is a thread running, so it adds some overhead, but it helps us to have as you're saying, collect the right information, especially when we do streaming.
Did you find an optimal bicycle route?
Not yet, so we're still working on this, not yet. It's still a struggle, so yeah. Hopefully, I'm still cycling, but it's as I said, sometimes it's more like human learning than machine learning. Maybe I learn more how to avoid traffic than any system can help me to.
All right, great, thank you. Round of applause.
Thank you very much.
Hello. Good?
It works great.
All right.
Yeah. Okay.
Perfect.
And then, there's just a little switch on the top if you want to turn it on and off.
Yeah. Hello, 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 hello. Yeah, it's okay, right?
Just don't
Yeah.
look at the wall over there.
Yeah.
Open source machine learning. Okay, we got 3 minutes.
Perfect.
How many of you, this is your first talk of the day? Nobody. Okay, good, because it's also the last one of the day. We'll give it about 1 more minute. Who traveled the farthest to be here today? Everybody's SoCal locals? Where? I didn't catch it. Panama. Were you in a talk earlier today? Okay. Panama. Anybody beat Panama? All right, Panama it is. That's the winner for this talk. Okay, it's 6:15. This is the last talk of the day, Saturday. This is SCaLE 21. We have Discovering Business Insights with Open Source Machine Learning. Round of applause, please, for Surya. Surya, take it away.
Thank you very much. First of all, I would like to thank all of you for making it to the last talk of the day. I feel very appreciative of you all that you guys make it to this talk. And so to begin with, today I'm going to talk about discovering business insights with open source machine learning tools. It's all about predicting customer behavior for the growth of your business. One thing I want to say is in this age of LLM, foundation models, generative AI, whatever you call, most of the people are trying to solve their use case using LLMs, generative AI and all, like large foundation models. It's true that they are efficient, they are effective in some way, but they come up with their own set of cost. And that constitutes a whole talk in itself for some other time. Today, I'm taking a step back and exploring some simpler models, simpler time series forecasting models, which can solve some useful use cases for businesses. I would like to give a shout out to my colleague Hema Viradi, who is a data scientist at Red Hat, and who was the equal contributor to this project as well. To introduce myself, I'm Surya Prakash Pathak, a data scientist at Red Hat. I'm based in Berkeley, California, and you can reach out to me in my email, GitHub, LinkedIn, whatever works. Happy to be connecting with you all. Yeah. So in today's agenda, I'll be talking about why customer growth is so important for anything, for business. And I'll go through some data sources, time series models, model insights, and talk briefly about one model monitoring tool. And I'll wrap this up with the demo. So this project was started, actually. The main goal of this project was to predict customer behavior over time for the Red Hat internal products. It's like predicting customer potential for different customers for different Red Hat products. Although the data was private, I cannot share it over here, but the model is open source, and it's adaptive in nature. So when I started this by talking about business insights and customers, I can adapt this model to any other organization. Let's say you have a GitHub, and you have contributors to some projects. And you want to track your contributors over time. And you want to identify potential contributors for your GitHub projects. You can also use this model. You can use this kind of framework. For this particular talk, we have extracted data or generated data using OpenAI credentials, just for that. That's all LLM we have used, nothing more. After that, we employed some time series forecasting model. We got some forecasted data. And using those forecasted data, we classified our customer base, or for other use cases, say contributor base, into high, medium, and low potential zones. Now, one of the reasons why this predicting of customer potential is very, very important is it gives you an advantage on which direction to drive your business through. For example, let's talk in terms of GitHub projects or contributors. If you know if you can predict your customer behavior over time, it helps you to it helps you to manage your investment on your projects. It helps you to manage your vacations as well. So manage your resources, manage your investment, and vacations for your projects. If you know what your contributor is, when your contributor is active or when your contributor is not active. Or if you can determine these are the high potential contributors and I should not lose them, you can reach out to them, give them offers, or give them good services so that they be in your organization. Or track low contributors seeking help. You can give them help and suggestions so that they move from lower set of low potential zone to the high potential zones. So in this way, you can manage your business or any kind of projects. So for time series modeling, we are using ARIMA to predict customer behavior over time. Basically, how much a customer spends every month. We are predicting with respect to ARIMA time series forecasting models. So let's move on to the data sets that we have used so far. This is the simplest ideal data set that we have used. The data set is generated using LLMs. So here we have different accounts. So one of the important thing that you need to understand about this kind of data set is it's not one time series data set, it's a multiple time series data sets. Say, for example, you have 50 customers, 50 contributors, or 100, or 200. You have 200 number of time series. And for each time series, you need to make a predictions. And out of that predictions, you need to classify those customers based on their predicted data. So here we have different account name 1, account name 11, different dates. In this case, it's varying with respect to every week. You have the actual value. You can correlate that with the contributor activity over time. You can correlate this with the revenue over time. And this is the predicted value from the ARIMA time series forecasting models. And this is the MAPE score. Now, what is the MAPE score? MAPE, it's basically median or mean absolute percentage error. It's the percentage error between the actual and the predicted value. Now, this is the good set of metrics for evaluating time series forecasting models. If the MAPE value, if the actual and the predicted values are equal, then MAPE is like 0%, very, very accurate, which is an ideal case. If the more the MAPE is, the less accurate your model is. Generally, it is considered, if it is from 0 to 10%, the MAPE is generally considered accurate. If it's from 10 to 20 or 30, it's considered moderately accurate. But if something above that, it's generally considered less of an accurate. So you need to change your model, add up features, do some data pre-processing, and so on. And again, train your model, and again, predict it. So that's how you go into the cycle of like making your MAPE as accurate as possible. So MAPE is a good metrics to look into to check whether your model is working or not. So we talked about the data set, and now let's talk about time series forecasting models. So here I'm highlighting two basic traditional time series forecasting models, these which are open sourced. And time series forecasting models are basically those kind of models which takes up the data points from the past, and based on that past trend, it predicts the future. You have ARIMA, which is the set of statistical models that caters to the group of standard structure of time series data. ARIMA, it's based on the underlying correlations. One interesting thing about ARIMA is for every kind of time series data, you need to define the hyperparameters to run the model based on autocorrelations and based on autocorrelations of the past values and moving averages of the past values. So for profit, which is somewhat similar to ARIMA, but it's more of an additive model and tries to detect change point. It's more like a curve fitting model. It's developed by Meta. It's an open source model. You can use it. So one good thing about profit is it's easy to use with default hyperparameters. So you don't need to define hyperparameter at each run. It's automatic. And it's, so this is based on a personal experience. I felt that profit works much better when your data is seasonal. So if every season your data is like, have some cycle of cases, then profit works pretty well. ARIMA, you need to define your own hyperparameters, but it worked pretty well for us because we were dealing with number of time series, like for example, 50 time series data, 100 time series data. So in order to run for all the time series data, we chose ARIMA. Now I told you we have multiple number of accounts and multiple number of time series. But for ARIMA, the catch is how to define hyperparameters for each one of them. Now, that is resolved so easily using the AutoARIMA package. With AutoARIMA, it helps you to determine the hyperparameter automatically based on the individual time series data. So here in this curve, you can see the training points given by the blue lines. The orange point is the test set, and the green line, green dashed line at the left-hand top corner is the forecasted points. So how we run our model is, we train our model, and we keep some data for the test set, and see through MAPE if our model working well or not. So here in this plot, we calculate the MAPE of 5.1%, which is pretty accurate for our use cases. Now, I'm again saying this MAPE is pretty accurate, but this also depends upon the kind of use cases that you are in. Sometimes your data is so sensitive that even a 0.1 or 0.2% difference makes a lot of difference. In that case, you need to have a very, very accurate MAPE. But in some cases, some flexibility is fine. So here we have the training set, here we have the testing set, and the forecasted set, these green points. Now, based on these green points, based on this forecasted data, we classify the ultimate customer set into different zones: high potential zones, low potential zones, and medium potential zones. If we move on, so generally, if there is an increasing trend, so one of the ways with which we calculate trend is by calculating the slope of that line. So if we consider slope as the trend setter of that line, then for an increasing trend, you generally get a higher amount of slope. Now, if your data points are not changing the value over time, then that is generally falls under the place of medium slope, which is constant slope. And if your data points is decreasing over time, over the x-axis, then those kind of data points are, then those kind of trend, those kind of slopes are generally in the negative side. And those are considered as low growth slope. So based on these three different classification of slopes, we classified our data, our customer base, into low growth, medium growth, and high growth candidates. You can do the same thing for your GitHub contributors list. You can track your contributors' activity over time, and based on your contributor activity, the forecasted data points, let's say you want to calculate your contributor activity for next month, and next month for the 4 weeks, you see an increasing trend, then that means those particular customer or contributors generally fall into the high contributing zone for the next month. That's the catch. If I see any contribution activity which is constant over time, then those kind of contributors can be regarded as the medium potential contributors. Let's see some of the examples over here. This is the case of low potential customer or low potential contributors. We can assume that way as well. So in this case, we see an up and down phases for this customer or contributor. Sometimes it is high, sometimes it is low. But if we really see the forecasted green points over here, this is the forecast for the next 5 weeks from the testing phase. So which means that for the next 5 weeks, what I'm seeing is this, for this contributor, they are contributing on the lower side, which means they will not be contributing enough. That's what I'm predicting it now. And that's why I've segmented them in the lower category. Now, we should not make this kind of result as the ultimate truth, but this kind of result can be a key indicator to inform the customer success team or those team which is in conversation with the customers or conversations with the contributors. If we see these kind of indicators, like for example, in this account name 45, it's on the low category. We can inform customer success team that so-and-so customer or contributors in the lower category zone, is there any problem with them? They can then check with their customer or contributor and talk about if there is any issue. If it is not, this can just be a false positive signal. Similarly, if we go to another example, which shows you the high category of customer, this customer or this contributor shows an increasing trend over the period of time, and for the next 5 weeks also, it is seen as an increasing trend. And this also calls for a key indicator or calls for further investigation from the customer success team, which means that if somebody is performing really well, if some contributor is performing well, if some customer is spending well on your product, you can give them some offers, you can give them some perks, so that they can stay there. they can perform much more better way. So I think the main aim is to keep the customer or contributor intact in your projects or intact in your business. So these are the ways which you can track those contributors or customers and just start the conversation if there is any problem. So these kind of plot can be a first-hand key indication to check with them if there's anything. Now, I just said this is the forecast for the, if I go back a little bit, this is the forecast for the next 5 weeks. There will come a time after next 5 weeks, you will again need to run that model again. And after that 5 weeks, again need to run that model so that you will constantly get the signal of which customers are in the lower zone, which customers are in the higher zone or contributors. So it's not a static type of model where you run once and everything is resolved. But it's something like a dynamic model where you run at every interval, every month, every quarter, or every 6 months or year, and reanalyze your contribution. Yes, sir? Yes, yes, sir. So when we run our model, we check our evaluation metrics again. Yes. And that brings me to the next point. So let's say, if I need to run my model for 12 months in a year, what do? I need to check that evaluation metrics value at each point to make sure that my model is working well. Because what could happen is a concept of data drift, or data might change at some point of time, which might have some effect on the model. So because of these kind of changes, there might be some change, there might be some feature change, there might be some feature missing. So all this kind of thing, if you are running a model at every instant of time, this kind of model monitoring tools will help you to track your model progress. So MLflow is an open source platform for managing ML lifecycle, including model monitoring. MLflow provides a variety of tools for model monitoring. You can track metrics and logs. Whichever metrics you want to track, you can log over there, and it will be logged in automatically. You can visualize model performances, and you can also set up an alert if there is any change in the model performance. Like, for example, if you can also set up an alert for your MAPE values. Like, if you run it, and if the MAPE score is above 10%, then just send me an alert. You can also set up those kind of things with MLflow. If we need to go to, so here's the UI. So this is the MLflow which was deployed in OpenShift in our Red Hat. So here's a simplest example of how can we track these kind of models. So this is the experiment customer growth model, which I have named. And these are the 2 runs. So this is the 2 different runs I have made. So this is the first run, and here's the metrics, the MAPE value that I have pasted over here. Like, this is what I have calculated. This is what we have got from the model running. And if I go back, if I go to another run, here's another metrics, MAPE, which is like 5.3. So there are 2 things changed in between the 2 runs. One is the MAPE score. It's just because it's not the fault of the model, but it's just I have changed the unit. I've changed the unit from 0.5 to percentage. So generally, the MAPE score is from 0 to 1. If it is there, then 0.5 is equivalent to 50, or like 5% or something, right? So just the unit is changed. So in these 2 cases, and if, say for example, if you have 10 different runs over here, how should you visualize these things? You can also visualize by creating some kind of chart, let's say bar chart. So if I add this, so here in the first run I have this 5.34% MAPE. In the second run I had like 0.05 MAPE. So these are different values of MAPE. Consider, let's for example, you have 10 accounts or like 100 runs. You can also visualize if the MAPE has surpassed the threshold value or not. So these are some of the cases where we can look into through MLflow or like, yeah, just things. So now, next thing I want to go through is this repository, which is customer growth model. This is our project repository. So this repository, whatever results I have shown you today, is the code is already over here. The two main folders of this repositories are data and notebooks. So in the data folder, you have the raw data, which was generated from using LLMs. And in the process data, you have the prediction data set, you have the label data set, which, so I can show you along the way. So if you go to notebook section, so first notebook is growth model generate data. And if I go over here, this is the growth model generate data notebook. So here you can see how we utilized OpenAI API key to generate a data set, tabular data set for working for this talk, for this model. So you need to supply the API key in the environment variable. You need to give it a prompt. So the kind of prompt I gave is like, make sure it's an account number and make sure the date is between January and July, just random. And then I made sure that a couple of accounts have increased amount over time, decreased amount over time, and medium account over time, so as to I can have some variety to experiment with. So this is the kind of prompt I gave it to the model. And so I'm looping through each account and making a request to this OpenAI credentials. So with this request, and there's some data pre-processing steps that I go through, and ultimately I'll get the data set like this. You have the account name, you have account one, different dates, varying weekly, and this is the revenue. So this is the data that I save in the data folder. Once you generate this data set, we move on to model forecasting notebook. In the model forecasting notebook, you import all those packages for time series forecasting, ARIMA package, which is from PMD ARIMA, and mean absolute percentage error. You already have this package over here. So you have this data set first. Now, generally, in a real world situations, you might need to go through a lot of data pre-processing phases. Like, I just want to give a shout out to the talk that happened earlier today about chaos and tsunami, data tsunami from Cali. They were talking about all those GitHub data, which is so enormous that it's very difficult to at least like manage and make sure it's there, right? So that is some challenge which we go through, and I've skipped that step over here completely. I've just shown you what happens after that. So in this case, to come to this level of data, we need some data pre-processing, we need some feature correlations, or we need to understand the feature importance, which feature is important for this model. So we need to select all those things. Those are there. So here is one of the example where we create our own features, a feature called tenure. So we didn't have this feature in our data set. So how we created this tenure is we assumed that tenure is something for which we have a non-zero value. If a customer is spending that month, then that month is regarded as +1 tenure. If the customer is not spending that much that month, then that month is regarded as a 0 tenure. So that's how we calculated the tenure, and it gets summed over the tables. So it can act as a feature for our data set. And then we go through, so there are two stages over here. First is the train and test and evaluate. So once we evaluate our model, then since it's the time series, we retrain our model into the whole data set and then forecast it. So first phase is the actual value and the predicted value. We predicted it for different accounts. Account one, every accounts are there. So there's like actual value, predicted value. Once we go through this, we calculate the MAPE, and here I've highlighted what's the accurate MAPE, what's the unacceptable MAPE, and all. So this is the calculation part of the MAPE. So here we have actual, predicted, and MAPE values. And we now save all those results in the data folder again. Now, once we have the considerable MAPE of like 5%, which is pretty accurate for our model. And this 5% is like the median MAPE that we have used. We want to see how, like, we can see the MAPE at every line, right? How do you calculate the single score for all of them? How do you represent a MAPE with a single score? So to get an average value, we calculate the median. So here we have the model forecasting algorithm, and then we forecasted the data for the future dates, not for the current dates. So once we have the account name, data, and the forecasted value, our next step is to take this data forward to segment the customers into different zones. And for segmentation, we calculated the slopes of the forecasted value. And that is what we have done over here. So in this case, we have labeled the customer potentials based on different forecasted data. So we have the accounts, date, and the forecasted values over here. We calculate the slope here. And based on each level of slope, we level them. And we level in such a way that we defined a threshold for each one of them. So if we consider different values of slope from minimum to maximum, minimum, we take it as 0 percentile. Somewhere in the medium, we take it as 58th percentile. And the maximum, we take it as 100 percentile. We classified slope in such a way that whichever account has slopes less than 30th percentile, we take those accounts as low potential accounts. And for those accounts which have the slope, that value that lies above 75 percentile, then those kind of accounts are considered as high accounts. This is completely based on our assumption. You can have your own assumption. Sometimes you might think that above 60 percentile is a high account. So it's completely based on your assumption. So it's completely flexible. And depending upon your use case scenario, what you want, you can define it your own threshold. So giving the threshold, I classified different accounts into high, low, and medium. So here you have the classification, everything. So once we have this classification results, we can send these results to the customer success team, and they can identify high, low, and medium, and they can recheck their customer, recheck with their contributors, recheck with their customers. In the next case, just a visualization perspective, we try to plot a couple of accounts. Like, for example, this is the high account over here, as we saw earlier also. So this is like the increasing kind of slope. The next is although it shows over the whole range, it shows somewhat of a constant kind of a slope. But for the next 5 weeks, it shows lower, so which means that it is low account for the next 5 weeks. Now, the third case over here, we can see, although it is also similar to somewhat the above one, but for the next 5 weeks, it shows both minimum and maximum. Like, it goes lower and it goes above. So overall, for the next 5 weeks, it shows somewhat of a constant slope. So if you take an average of all of them, it falls somewhere in the middle. It doesn't change. So we take this kind of account as some kind of medium account, where more or less there is a constant slope. So once we have these visualizations, once we have all these results, we can log in the MAPE values in the ML flow. For ML flow, we have to supply, since it's deployed in OpenShift and we need to have some credentials in order to access them, we have to supply the ML flow URL and ML flow tracking token in the environment variable. And once we have that, we can just log in our MAPE values, calculated MAPE values over here, 5.34, into the ML flow login. And if I want to put this into a pipeline, so at every round, it will go through it. Once it runs this notebook, it will automatically log in the MAPE values in that ML flow segment. So this is how the whole process happens. This is how we can check the model. This is how we can run the model and run at every instant of time. Having said that, I'll go back to my slides now. So demo is done. So one of the main key takeaways from this talk is it's not just for a business use case. It can be used for any kind of time series use case. The main thing that is needed is time series. Another thing that is needed is what do you want to achieve? The main asking the questions, like for example, you have the GitHub projects, you have the GitHub contributors. What do you want to see? What do you want to track? For example, in this case, we can consider metrics like interaction frequency, how often you interacted with the GitHub member or GitHub contributors. Does that interaction helped in the contributors' growth or not? So these kind of feature sets can be added later. And these are some challenges in GitHub. These are definitely some of the challenges in this kind of customer interactions, because a lot of features are there which is very hard to extract. Like if you are running an organization in GitHub and you have to converse with contributors at every now and then is there a method to record that kind of conversation as a metric in a table and add this as a feature set in this kind of model? And if we can add those things, if we can add those features as a feature set, it's much, I think the MAPE will be much, much accurate in that case. So yeah, thank you. And here are my, I think this is the customer growth model GitHub repo, and the notebooks the links to the notebooks are here. You can definitely check them out, and if you have any time series, you can apply these models to your own time series, and if you have any issue, you can just open an issue in this repository, and we can have a conversation over there as well. Thank you very much, and let me know if you have any questions. Thank you.
Do we have any questions?
Yep.
Hi, thank you for the talk. I'm actually really, really into time series.
Sorry?
I'm actually really into time series and stuff like that,
Yeah.
so I do have some questions.
Yeah.
It's actually my expertise in it. When you compare Arima to Profit, you mentioned that Profit is better at seasonal, but Arima never had to take into account seasonal because there's Arima for it.
Yes, exactly.
Yeah, and then you also mentioned creating features, like feature as in into a new feature to add into the time series.
Yes.
Is that so as far as I know it, regular Arima doesn't take features unless you're using Arima X.
Yeah. So what you're saying is, the first question is, you're saying that Arima does a seasonality, right? So one thing we are not addressing seasonality over here is because our accounts is multiple. So let's say one account has a seasonal base. Another account might not have a seasonal base. So in order to make sure everything works for all of them, like we are running it, right? We cannot run Arima for one and Arima for another, so it's a bit tricky out there. So just to make the matter simple, we cut out the seasonal part. But from the PMD Arima package, Auto Arima, you can adjust the seasonality over there as well. Like if you have a package PMD Arima and you can call the function Auto Arima, in the argument section, there's a seasonal part where you can on and off over there. That's the one. Another thing about your question is, what was that? Like,
it seems like you're
yeah, feature, right? So that's a tricky part in the time series. So again, in the PMD Arima package, as an exogenous variable, you can add up the features over there inside the argument itself. But the condition over here is if you are predicting for the future where you don't have any value for the feature or the target variable, it's a complicated thing. But sometimes you don't have the values for the target variable, but you might have the future values for the feature variable, right? You got it?
Yes.
Yeah. So in that case, while predicting it, you can supply the feature values as an exogenous variable in the PMD Arima package in the time series. Yeah.
So the model isn't like vanilla ARIMA. It seems like they're using ARIMA X, which is like a modified version of it.
Yeah, I think it looks simple. It's like the one direct statement. You just put the argument, you just fill in the boxes, but most of the things goes back end. I think so. Yep. Please take a look. Yep.
Any other questions? All right, I think we had a pretty good group for this late in the evening.
Thank you. Yeah.
Great, thank you. A round of applause, please.
Thank you very much. Yeah. All right.